staff, which is going to primarily be the consumer of these resources. On the other hand, when you talk of cloud, now this on-prem arrangement is also sometimes referred to as private cloud. And when you use the term cloud, essentially we already understood this. Now that we are referring to accessing the resources over the internet. So anybody can go, even an individual user like you and me, we can also go and consume those resources. So this is basically what we refer to as public cloud. And when some organization or when some customer wants to leverage the benefits of both the sides, they can go with an arrangement called hybrid cloud, which means they will come up with an architecture with a setup which will allow them to keep on using their on-prem resources, the data centers, along with, if they may want to leverage the benefits of the cloud, AWS cloud resources or services, and they can kind of access them together by allowing these services to be accessed across these two different deployment models. So essentially, hybrid is a mix of on-prem and cloud. And again, AWS has certain services out there like AWS Outpost, which helps you to establish this hybrid kind of deployment model. So what are the benefits of AWS cloud? Why at all should I be attracted towards AWS cloud and try to adopt it and migrate or kind of build applications on cloud? So what are those benefits? And as of today, if you take a simple look around the industries, the world, you will find that more and more organizations, more and more customers, be it startups, be it enterprise organizations, be it SMEs, be it public sector, private sector, whatever. Almost everybody is kind of in a race to adopt the cloud as quickly as possible. So definitely there should be some benefits that they might be looking at. So what are those benefits? So we'll be very specific and we'll talk about the 6 major benefits that we can think of or kind of categorize, and all other benefits will come under those 6 categories. So the first and foremost is the reducing the risk of your capital, which is basically trading your capital expense for variable expense. Now, capital expense, here we are kind of referring to 2 business terms, the capital expense and the variable expense or the operational expense. So sometimes it is also referred to as CapEx versus OpEx. So capital expenditure versus operational expenditure. So what is a CapEx or capital expenditure? Capital is basically your money, your money that you want to invest in your business upfront. Okay, so that is called the capital, whatever you're going to invest in your business. So if you are trying to set up, say for example, a computer institute, so whatever money you are going to spend upfront for setting up, for getting the office space, for maybe purchasing the furniture, purchasing the hardware, software, whatever. So that upfront investment is called the capex. Operational expense, on the other hand, is the money that you are going to spend while carrying on with the operations of that entity. So the electricity bill that you are going to receive or pay, or the staff salary that you are going to pay, maybe some facilities in your office that you're going to take up, like the tea, the snacks, and so on. So all these are operational expenses. Now, at the same time, let's just take one simple example. You may want to have your own office space. You want to own it, which means you're going to purchase the land or purchase some office space, versus you may want to rent some office space. You may want to sign some lease for your office space. Now, what's the difference? Of course, when you have your own office space, that is, you are owning it, you are owning that asset, you will have to spend, you will have to invest the money upfront to purchase that whole office thing. Maybe it's 1 CR, maybe it's 10 million, 1 million, whatever. Versus when you are signing a lease, so that 1 million, again, maybe you are spending 1 million, but then that will be spread across maybe a 5 years or 10 years timeline. So which means you are not spending it upfront, you are not investing it upfront, but you are paying as you go. So as the time passes. So which means you have reduced the risk of your capital. Why? Because now on day zero, when you are starting your operations, you never know whether your business will succeed, whether the break-even point will come after 1 year, 2 year, 3 year, 5 year. You don't know that. How your business will move ahead from there. So will you start earning profits? Will you not start earning profits? Will it be a good idea? Will it not be a good idea? And so on. So essentially, what you are doing with AWS is not just satisfying the requirements of startups or some smaller players. They are fulfilling the requirements of some of the players which need to implement the most stringent security measures. Now, when AWS is providing those features or services for these kind of players, the other players who may not necessarily require that kind of security requirement, but still these features and services are at their exposure as well without any added extra cost. So this is what we really mean by massive economies of scale. Stop guessing capacity. Now the previous two things we have talked in terms purely in terms of money, cost. Now coming to the technical parts a little bit of. So what are the technical advantages? Stop guessing capacity. Now this has been a $1 million question in the industry. So whenever some organization, no matter how big or how small, even if they need just one server to run, $1 million question is how many servers should I actually, what capacity should I actually put in place on day one, or maybe after 10 days, or maybe after 15 days. So to start with, you may recognize that, okay, you may not have too many requests coming up, maybe 1,000 requests per second, but you realize that maybe 6 months down the line or 1 year down the line, this is going to grow to 10,000 requests per second, say for example. So a question for you at the moment is, should I provide the capacity which is sufficient for 1,000 requests per month, or should I immediately provide a capacity of handling 10,000 requests per month? So you know that in future things may change. So should I be ready for the future today, or should I let it be done when the time comes? Great. What if after maybe 1 year down the line, the requests reduce from 10,000 to 5,000 requests per second? So how it is going to look like? Or maybe if there is a sudden surge in the traffic because of some promotional activity or some other reasons. So how are you going to handle that on-prem? So that is a big question. So either you may end up setting up overestimated server capacity, or you may end up serving the underestimated server capacity. So these are the two outcomes that may result, that may come in the on-prem environment. Now, because why this is such a big challenge? Because you will be actually acquiring the physical hardware, the physical assets, which may be later on difficult to dispose of. So that is a real big challenge. On the other hand, when you are using AWS Cloud, you have services and features like, for example, AWS Auto Scaling or Ec2 Auto Scaling. So this allows you to automatically scale out or scale in, which means provide more resources, more servers as required if your traffic goes up, and at the same time reduce the number of resources if as and when the traffic goes down. So based on your demand, based on your patterns of the traffic going up and down, you can automatically, dynamically set up certain rules, set up some alarms, which can handle this automatically. And at the same time, also allowing you to set up some maximum and minimum limits of the resources so that you do not burn a hole in your pocket. Great. So this definitely is a very, very attractive benefit for the organizations. Increase the speed and agility. Now, in a traditional setup, you will recognize again because you are dealing with physical assets. So there is a good chunk of time between when you place the request for an asset and by the time it actually comes to you and you are able to use it. So there is a whole lot of process that needs to be followed, right? So as you can see on the left hand side, there is a purchasing request being raised, which may kind of go through a certain path. Excuse me, please, folks. Which may have to follow a certain process path. Like first it goes to the middle management and the senior management, then the accounts. When it gets approved, then it goes to the vendor. The vendor arranges for the asset, delivers it to your organization, to your team maybe. The IT people prepare it so that it can be usable. And finally, the team which requested for the asset gets it to use. So this could be a period of maybe from some weeks to some months before they actually start getting using it. On the other hand, when you talk of the AWS resources on AWS Cloud, it's just a matter of clicking a button, just a few settings here and there, and you are ready to use your resource. Also, when you do not need it, you can simply dispose it off. You can simply let it go. So which means you are not going to incur any charges after that for that particular resource. Great. So this advantage provides a lot of flexibility and definitely also increases the speed where you can provision the resources and you can dispose them off when they are not required. So again, it reduces the cost risk for any organization and hence becomes a very interesting point. Stop spending money on running and maintaining data centers. Now this one sometimes people take it in another aspect. So here we are not talking of laying off any IT people or admin people. If you look a little bit more closely to this point, you will find that here we are talking of setting up the data centers itself, which means the very first thing that you need to spend your money on is the space, the office, the physical space, where you are going to put up your rack and stack. You are going to rack and stack your servers. You will be implementing the redundant networking facility. You will be putting up a redundant power supply. You will be required to put up physical security, perimeter security, software security in place, and you will be spending money around that. So that is what you can definitely say, because AWS infrastructure already has that in place. So when you talk of AWS infrastructure security, there is a perimeter security, environmental security, highly redundant, highly available setup already in place with high network bandwidth. So which you can just go ahead and use it. That's all. So you do not need to spend money on these kind of activities. So that definitely is a big advantage to the organizations or the customers. Now, last but not the least, one of the very interesting advantages here or benefits here is go global in minutes. Now, what does this mean? Now, think of a scenario where you may have launched some application to start with, some workload to start with, maybe let's say in India, and it is catering to the Indian diaspora. By the time gradually it gains popularity, and users from other geographic locations are also have also started using it, and they are kind of consuming it more and more. So maybe people from US are attracted to this application, and there are a lot of new users started using this application from USA location. Of course, you have set up all your infrastructure in India, somewhere in India. So the US people are going to observe or witness some latencies, higher latencies, and they start complaining about that. Now, as a service provider, as an organization, in a conventional setup, the only option you have is to replicate the infrastructure, replicate all these services into somewhere in US in some physical location, and let these users experience a better user experience by lowering the latencies. Now, again, when I'm saying that, it looks quite easy, but to set up a new data center in some another country, in some other geographic location, that's not going to take anything less than probably a few months to maybe a year, something like that. There are a lot of challenges you need to take care of, not just the technical ones, but also cost-wise, but also taxation and any macro environments of that particular location. Great. So where does AWS Cloud fit in this scenario? Since AWS has already their infrastructure, their data centers laid out across the globe, so which means pretty much you can, if in a certain scenario, the similar scenario, if you want to set up an infrastructure, set up the environment or where you can run your workloads, you can just go ahead with the click of a button. You can change the region and you can deploy a similar infrastructure which you're already running. You can replicate that on any other geographical location. So which means you can go global in minutes. Not just that, AWS also has certain services or something called as points of presence or edge locations, which we'll be talking about later on, which supports things like content delivery network, CDNs. So there is a service called CloudFront, which is basically the CDN service from AWS, which means for a similar situation, if you think that it is okay just to distribute the content globally, to cache the content globally, that can also be achieved with the help of cloud services like CloudFront, which again is going to deliver the content to the end users across the globe with minimum latencies. So these kind of services and that kind of physical assets layout across the globe ensures that you can go global in minutes without spending a fortune on these setups. So essentially, these are the 6 benefits that AWS Cloud provides our end users or our customers. Great. Just a second, folks, before I move to the next slide. Okay, so somebody is asking about the labs. So I'm really sorry, this is not a full one-day course. This is just a webinar, so you may not have labs. Of course, I'll be walking you through some demos as and when we come to those things. But there are no labs for this particular webinar. Cost training that. Afreen is asking, you have sent a link of training, and that what we need to do. So Afreen, this link that Nivea has shared with all of you, just go to that site, and there is this site called portal called explore.skillbuilder. So you just need to sign up there. All the courses present in that particular portal, this is the AWS Digital Learning Library. All the courses as of today, they are free of cost. So you can, all the digital courses, they are free of cost. So you can just go ahead and whatever course you feel like the CP that Nivea has shared, you can just go ahead and you can enroll in that, and at any point of time on a self-paced learning base, you can go ahead and look into that course. You can go through that. And that's the same thing that we are discussing right now. Great, and not just that, there are many more courses out there. Arun, the link is on the chat window. I'll request Nivea to please put that on the questions panel also for all the participants. Okay, again, I'm once again repeating the answer to this question. Any certification vouchers post this session? Sorry, as I mentioned, this particular webinar does not entitle you for any certification discount vouchers or any completion and things like that. Yeah, sure. I'll request Nivya to please share the explore.skill builder link on the questions panel as well as chat with all the participants. Okay, great. So coming back to the slides. Now, next thing is whenever we are putting our workloads in our on-prem data center, we have a feeling like, okay, they are safe because we are the one who are managing that. Now, of course, we have this skepticism when it comes to the cloud because we are putting our workloads, our data, and other stuff on someone else's infrastructure. So, is it really secure? So again, AWS security ensures because the AWS infrastructure puts strong safeguards in place to help protect customer privacy. All data is stored in highly secure AWS data centers, and AWS itself meets the various compliance requirements. It manages dozens of compliance programs in its infrastructure, which means that segment of your compliance have already been taken care of. So, with respect to the infrastructure, with respect to the physical layouts, data centers, AWS itself is making sure that it is meeting a lot of compliance and standards. This in turn helps you to save money and scale quickly with respect to security. Now, what are the different AWS services categories that you can work with? So again, if you take a look at this particular slide, which is right now on the screen, you will find that you name it and you get it. So no matter whether it's AR, VR, whether it's business applications, whether it's IoT, machine learning, whether it's mobile workloads, mobile application workloads, security, identity compliance, even satellites, or even quantum computing. So you will get something, some service related to that. So no matter what kind of workload you might be working today, you will find a relevant service in AWS that you can use for your use case. There's a broad category of services, and every category has a broad spectrum of services available for that use case. Okay, great. Okay, so there is a question on the question panel. How our data is safe? Let's say if we put data in cloud hosted in US, how do we ensure that US government will not steal our data? Okay, so to answer this question, see, first of all, you need to understand that you cannot just place your data anywhere. And your question is correct in that sense that if my data is actually being physically placed in US, so you need to understand the terms and conditions. If you know that this kind of scenario that you're mentioning about that can happen, you should not be using the regions for storage services which end up in somewhere in US. Rather, you will you will create those resources in the India region. So for example, as of today, we have Mumbai region, which is in India itself, which is based out of India itself. So in that scenario, in that case, the scenario that you are mentioning will not be possible, and hence your data will be safe. And please remember that whatever regions you are selecting, we will talk about more about regions and services and how they are related in a moment. But just to answer your query, so please remember, whatever locations you are selecting for your services in AWS, within AWS, you need to be aware of the consequences, uh, the government laws, the regulatory laws, the legal requirements. So based on that only, you are going to make a decision that as in where to store your data, and not just data. I mean, when we are talking of security of data, privacy is one thing and security of data is one thing. So when we are talking especially of security, we are referring to the encryption part, the encryption in motion, encryption at rest, and things like that. When it comes to the privacy part, of course, the scenario that you are talking definitely makes sense. But again, it's not that you always have to save your data in US location. No, that's not true. If it is a requirement, of course, you have to do that. And if it is a requirement, of course, you have to oblige by their terms and conditions, their regulatory requirements. But if it is not a requirement as such, you are free to store your data in any of the regions. So it could be in India region, it could be somewhere in Europe, maybe in Australia, Singapore, or wherever. Okay, so you have a choice for that. Okay, so these are the different AWS service categories. Now let's move on to AWS Global Infrastructure. So the last benefit that we talked about, go global in minutes. How is that possible? How AWS makes sure that your data is secure, it's highly available, and things like that. So AWS Global Infrastructure is what interests us, and let's take a look at that. Now, again, let me also make use of my whiteboarding here, which will help me to explain it in a better way. Now, think of this as the world map. Sorry, I'm so sorry. Let me. Okay. So let's say this is your world, and across this whole world we have AWS cloud. So natural disaster or some man-made disaster happens to one availability zone, the other availability zones will still not be impacted by that event. Yeah, sorry.
Yeah, sorry to interrupt you. We had a small audio loss for like the last 3 minutes, audio and video loss. You're just back online. We've lost you again, Amanpreet. Can you check?
Okay, I'm not sure. Yeah, I hope that. Okay, sorry for that interruption. So yeah, so if it has been just a couple of minutes back, probably yeah, I'll repeat the content. So basically, I was talking about the AWS global infrastructure. So let me start from the slides once again. Okay. So one of the benefits that we talked about. It seems, can we start from AWS infrastructure, global infrastructure? Yeah, that's what I'll be starting with. If I can get a quick confirmation from all the participants, I hope I'm audible now. Okay, great. So thank you. Thanks for your confirmation. Okay, great. So I think it was, if it is 3-4 minutes, it is probably the global infrastructure that we wanted to start with. Okay. Now, one of the benefits that we talked about in the benefits slide was go global in minutes. How is that possible? It is possible because of a distributed or the AWS infrastructure spread out across the globe. So here are a few terms that we need to be comfortable with. So one of those terms is regions, as you see on the screen. And then I was trying to explain these things with the help of my whiteboarding. Just a second, folks. Seems to be some interruption in network. Okay, looks good. So coming back to this whiteboarding. So what is a region? So region is basically a group of or a collection of availability zones. 2 or more availability zones. So it is going to be always greater than 1 AZ. Okay. So every region will have at least 2 availability zones in it. What is availability zone? Availability zone is basically a collection of data centers, a cluster of data centers, 1 or more. So it will be greater than or equal to 1 data centers, whereas a region will always be greater than 1 data center. So at least 2 or more than that. How many data centers would there be in an availability zone? At least 1 or more. Great. Now, to understand region, it's not kind of, strictly a country or strictly, a continent or things like that. It is just some kind of, logical segment to meet the needs and requirements of the end users, of the customers. So let's say this is region 1, and right now it displays 4 AZs in it. The AZs as such, they are placed physically in such a manner. So they are, say, for example, maybe a distant apart, like 100 kilometers, 150 kilometers from each other, something like that. So that in case some event happens, some unfortunate event happens, like maybe a flood, maybe some earthquake or something like that, or maybe some man-made disaster. So if one AZ is impacted by that, the chances of other AZs getting impacted are minimal. So that AWS can provide you a high availability of fault tolerance for your workloads in case you will be using either the AZ explicitly in your architecture, or maybe some services using it implicitly. So this is the overall global infrastructure layout. So 3 terms that we try to understand here is data center, which is actually the physical data center where the servers are stacked up, rack and stack. The networking layout, the network connectivity, and please remember, for that matter, all the availability zones in a region and all the other availability zones in other regions, they are redundantly connected to each other, so that there is no single point of failure ever. Okay, great. So this is how the global infrastructure looks like: data centers, then availability zone, which is a cluster of data centers, 1 or more data centers, and then the region, which is basically a collection of 2 or more availability zones. The purpose of having at least two availability zones in every region is the high availability and fault tolerance, so that you can design an architecture for your workloads which makes use of multiple availability zones. So in case even if one AZ goes down, your workload will still be running with other AZs. So that is the important part to understand. So here you see what is availability zone. Basically, a collection of data centers, a cluster of data centers. So here we are finding three AZs. So this AP Southeast 1, this is the region. Sorry, this is the region. And then you have three availability zones, 1A, 1B, and 1C. And all these availability zones are nothing but a cluster of data centers. Now, similar to Singapore, like AP Southeast 1, you may have a Mumbai region, which is AP South 1, and you may have other regions like 4 US regions, US East 1, US East 2, US West 1, US West 2, and so on. There are government regions, and there are different regions across the globe. If you go to Europe continent, you will find multiple regions there, like in Ireland, Frankfurt, and Paris, and so many regions. Similarly, you will find regions in Australia, Singapore, and so on, Japan, and so on. Okay, these are the regions, availability zones, and data centers. Okay, there's a question: will the cluster have duplicate data across regions? That depends, Ritesh. Certain services, across regions, there are no services which will do that automatically for you. You will have to explicitly enable. So the features would be there. So for example, if you are talking of, let's say, S3, the storage service, that will allow you to replicate across region replication of your data, but it will not be implicitly enabled. You will have to go ahead and enable that, because there are certain factors that need to be taken into consideration, and that can only be done by the customers. So the feature would be there, but it would not be enabled by default. For certain services, yes, you can go ahead and you can just enable those features, and the data can be replicated across regions. Within a region, across multiple availability zones, there are certain services, again, for example, S3, which will replicate your data automatically to different availability zones within the same region. So that definitely is allowed, or that definitely is in place. Great. So I hope that answers the question. Now, with so many regions available, and why cross-region replication is not enabled by default for various services, let's try to understand. So there is a question, there is a very important question that comes to the mind, that if there are so many regions available, which region should I select to deploy or to provision my resources on AWS? So there are 4 factors to it. The first and foremost is the data governance and legal requirements. So say, for example, if you are trying to store the demographic data of some users from maybe European region, then you know that they have very strict GDPR norms in place, and you need to follow that. Today, with Indian government saying that the Indian users' data belongs to India, which means you cannot take it outside India. So again, if your end users are mostly Indian users, you need to make sure that their data is being stored within the Indian boundaries. So in this manner, depending upon different countries, different geographic locations, rules and regulations, or any industry compliance like HIPAA compliance, like PCI DSS compliance, and all that stuff, you need to make sure that whatever data you are storing, it has to follow those data governance and legal requirements very well. You need to oblige by that. Okay. So that is the first and foremost requirement to select the region for your workloads. Number 2, proximity to customers. Of course, this is one of the very most important things out there. Today, the research tells us that if a user cannot get to see the response within maybe 2 seconds to 3 seconds, they just kind of move out of the site and they never come back to it most of the times. So which means you don't want to lose your end users, your customers, your own customers. So you would like to make sure that they witness or they observe the minimum latencies. You will try to be as close to your end users as possible. Okay, so that is the second most important factor that one needs to consider while selecting a region. The third important factor is availability of a service within the region. Now, please remember, AWS may have hundreds of services out there, but it is not that every service is available in every region. So please be aware of that. The North Virginia region, which is US East 1, that will definitely have all these services because all these services are launched from that region. And then gradually these services are made available to other regions as well. But will a service be available to a particular region? That's not guaranteed. Will a region, any other region will have all these services within it? That's also not guaranteed. It may, if it is not available today, it may be available tomorrow in a particular region. But that is simply, a decision that AWS makes. And there are, behind the scene, a lot of factors around that. So there are no guarantees. So please be aware of this fact. I'll share one interesting link with all of you, and I'll just pull it on my screen. Give me a sec, please. So this link will help you to decide or to take a look at what services are available in which region. So let me open that on my screen on the browser. So here I'm going to type global infrastructure. And this takes you to the AWS Global Infrastructure page. And here you will find at the top menu, you will find a link called AWS Regional Services. Now, when you go to this page, you will see that it provides you a drop-down. Seems there is some network issue today at my end. Okay, let me try to change my Wi-Fi connection on my network connection. Just give me a second. I'm not sure what's going wrong today with my network. Okay, so basically on this page, I'll request Nivia to please share this link with all the participants so that they can open the same link on their own machines. So when you select that drop down, which will appear here, not sure if it is from AWS end or it is because of some network issue at mine. Okay, this is how it looks like. You are going to select from this drop down. So this shows you various regions available. Say, for example, I select Singapore. Now, let's say, for example, I want to use a service called Amazon Inspector. So on this page, I search for Inspector. And then you find at the bottom, I have typed Inspector, but I could not see any matching services found in this list. If I change this region from Singapore to say Mumbai, and again I do a same search, and there you see I can find a service in Mumbai region, Amazon Inspector. So it means it tells me that the Singapore region does not have this service available as of today, the Amazon Inspector, whereas the Mumbai region has it. So similarly, for many other services, you can observe the same behavior. So certain services will not be available in certain regions. So please be aware of that fact. So the third factor, important factor, is the service availability. And last but not the least, the cost. Now again, please remember that the cost for the same service, for the same amount of consumption, the cost may vary across regions. To illustrate that fact, let me once again go back to my browser, and here I'll be opening another tool the calculator.aws. I'll request Nivea to please share this link with the audience, the calculator.aws. So here with this calculator.aws, this is an online tool available for public in public domain. So which means anyone can go and use it. Nivea and others, if you can please confirm if it is my network which is working so slow, or maybe I'm getting a slow response from the AWS end. Not sure. So it's taking too much time to open the.
Amanpreet, I opened the sites, it's working fine. So maybe there's a small delay at your side.
Okay, thanks, Nivea, for that. Okay, great. So on this page, when you land on this page, you see this create estimate button. I'll just click this. And here I'll search for, say, for example, EC2 and click on configure. And it will give me the options to select, to get a quick estimate for some specification, Ec2 instance specification. So I'll select Linux as an OS, and I'll go with 4 virtual CPUs and 16 gigs of memory. Basically, I'm selecting P4G.extra large instance type, one quantity for 100% utilization. I'm selecting a standard reserved instance for 1 year price, all upfront. Or no upfront maybe. So the monthly cost is 61.54. Now the important thing to remember here is that the region that I've selected is Ohio, and the cost per month with this configuration is coming as 61.54 US dollars. I'll keep all these rest of the specifications same. I'll just change the region. I'll go to, from here I'll go to maybe Mumbai. So now I'm trying to check the cost of an EC2 instance with the similar specification, but instead of Ohio, now I'm going to check it in Mumbai region. So if you go down, you see all these specifications are same: Linux, then P4G.x large, quantity 1, 100% utilization, and standard reserved instance with 1 year commitment and no upfront cost. But now the cost comes to 41.39 US dollars. So for the same instance with same capability, with same hardware configuration capacity, now if I provision this instance in Mumbai region instead of Ohio, so you can see I'm straight away saving 20 US dollars or more than that probably per month. So please remember, the same service may have different cost across different regions. So this is very important to remember. Okay, and this is the fourth factor that you will take into consideration when provisioning your resources or selecting a region for provisioning your resources. Now again, what you just saw is with respect to EC2. Now maybe in case of S3, you will find that Mumbai is expensive as compared to Ohio. It may happen. So it's not that if one service is providing you lower cost in one region as compared to another, the other services will also reflect the same behavior. No, that's not true. So you need to use this calculator on AWS to estimate the costs of different individual services with respect to different regions. But important thing is that costs may vary by the region. So please remember that. Okay, great. Now, another important term with respect to the global infrastructure is the edge locations. Now, as you can see, these blue circles on this slide, they are locations, and these are far more in number as compared to your availability zones, regions, etc. Now, what are these edge locations basically? Now, before I start explaining these edge locations, once again, I'll like to share one more interesting and important link. So when you go to this AWS Global Infrastructure page once again, and you take a look at this top link, region and AZs, click on that. And that will open up the page for you where you will find region maps and edge networks. So again, depending upon certain, the continents, basically this is how they have divided. AWS has divided the locations: North America, South America, EMEA, and Asia Pacific. So So these are the four different segregations that they have done for geographic locations. And for every location, these blue circles, these are representing the edge locations present there. So you will find that there are far more edge locations as compared to regions or availability zones. Again, on the same page, if you go to the overview link here, you will find the exact numbers. So like we have 26 launched regions, 84 availability zones, 17 local zones, then 310 plus points of presence, out of which 300 plus are edge locations. Okay, so we have 300 plus edge locations as of today. Great. Now, what are edge locations actually? So, if I have to put it in a very raw form, a raw term, you can think of edge locations as some sort of mini data centers or stripped down data centers. So while availability zone data centers provide you the full array of services that you can use from AWS, edge location provides you some limited number of services like CloudFront, Route 53, Web Application Firewall or WAF, AWS Shield, which is a service for DDoS protection, Lambda at Edge. So these kind of services, a very limited number of services provided out of the edge locations. And again, what is an edge location? So think of it as a mini data center. Great. So what's the purpose of edge location? The purpose of edge location is to be as close to the end user as possible. Now, as you can see, that the edge locations are so
हाँ बेटा ये लो बेटा जल्दी हो गेट लगा देगी सुबह गेट लगा जल्दी हाँ देख लो अपने साथ तू नहीं लाया हमारी क्या वो उस पर बेड पे लेटा दे ना मैं कहाँ से ले आऊँ भाभी दे दो हाँ नीचे मतलब डालो मतलब क्या आराम से आना भाभी सो रहा है पजामा में लेटूं
Okay, that's good to see. Things are back to normal now. Great. So let's resume with where we left just before the break. Okay. So the last thing we wanted to start with is how are we going to interact or what will be the different interfaces to interact with AWS services or AWS cloud. So in that regard, we have at least three, or in fact we have four ways actually. So first one of them is using the management console, which is basically browser-based GUI interface. So if I take you to my browser once again, so this is how it looks like. So I have kind of opened this by using console.aws.amazon.com, as you can see on my screen right now. Nivya, can you please confirm if I'm audible now?
Yeah, your audio is.
Okay, great, because some participants were still complaining. So thanks for the confirmation, Nivya. Okay, so this is my management console, and as I showed you, like if you type this console.aws.amazon.com, it will land you on this page, where either it will ask you to sign in using the root user email or the account ID or the IAM username. So right now I'll be logging in using the IAM username. So let me select an appropriate username here. I'll select test labs and then password. Sign in. Now since I have set up MFA code on my account, so I'll be required to provide that, and I'll quickly go to my authenticator app and get the MFA code for my login. And here I'm going to put it now. This is okay. So the code has changed. Just give me a second. It's 09 and 526. Okay, so once I have successfully authenticated, it will take me on the landing page. So this is a new interface. So you can see some services recently visited services are listed here. Then if you scroll down, it's going to provide you a lot of details out there. Okay, some sample solutions will also be there. And on this top right corner, it will show you like the username that you have logged in. Your account ID will be displayed here. How you have logged using the IAM user Aman Test Lab, and then here just next to that you have this regions dropdown. Now by default it shows you this dropdown with all the regions available. For certain services you may see global here. So for example, if I go to IAM service, which you will see later on, or maybe S3, you will find a global and all these regions will be disabled, which means that these services have a global scope. They are not kind of specifically confined to a particular region. But other services, you will find that they are specific to the regions. So this is one interface, the graphical user interface that you can use to interact with your AWS cloud services. So for example, if I click on S3 here, so it will take me to the S3 dashboard. And here you can now notice that instead of regions, it is showing me global. And if I click on this drop down, all the regions are disabled. Okay. Similarly, on the other hand, if I select, say, for example, EC2 service, and then I click on EC2, it will take me to the EC2 dashboard. But this time, this will be region specific. So now you see, right now I'm in Mumbai region, and it will not show me anything in my region because any EC2 instance, because I do not have any. But if I change my region to maybe Singapore, and then you will find some instances being displayed here, some EC2 instances being displayed here, which means I have already created those instances. More about that when we come to the EC2 instance part. But this is just to illustrate that how you are going to interact with AWS services using the management console. So here you see I have at least 2 instances provisioned in my Singapore region, and one of them is in stop state and one of them is in running state. Great. So again, this was just to illustrate you that there will be certain services like S3, like IAM, which will be global in nature, which means they are not confined by any specific region. Other services like, for example, EC2, they will be region specific, which means the region that you may have selected to provision those services, they will be displayed or available only in that specific region. Great. And this AWS GUI, graphical user interface or management console, is one way of interacting with AWS services. The second way of interacting is the AWS CLI. So command line interface, and using your local command line interface, whether you are using a Windows, Mac, or Linux platform, there is available called AWS CLI that you can use to interact with AWS cloud services from your command line. And the third way is software development kits. So these are the 3 different ways you can interact. On top of that, a 4th way is the direct invocation to the service API endpoints. So even that is possible. Now let me quickly walk you through the CLI part of it. So here I have my local command prompt on my Windows machine opener, and I have already installed the tool called AWS CLI. It is very easy. You can simply go to your browser of your choice, and let me Google here for AWS CLI, and there it goes, installing. Click on this. It will take you to the appropriate page. You can just go ahead and you can install it for any of your platforms, Linux, Mac OS, Windows. So for example, these are the installation details. You just go through them. Pretty easy to install. No prerequisites, nothing. It's a complete installer package out there. So again, I'll request Nivia to please share this link with the participants. So once you have installed it, the next thing is that you need to configure it with your credentials. So the command for that is going to be AWS configure. It will ask you for certain details like your access key ID, secret access key, the default region you want to work with, and the default output format. Now again, we'll come to this part when we talk about IAM. But right now, just to show you that these are certain things that you need to set up. So AWS, after you have installed the CLI, you will need to configure it with your credentials. To check whether you have successfully installed that or not, use the version command, version option with AWS, and it will show you the version that you have installed. Oh, sorry, should be on one. Right, so this is the version that right now I'm using on my local machine. Once this all is done, you have installed it, you have configured it with your credentials, you can go ahead and start using these services. So for example, right now I'm trying to list all my buckets in S3. So AWS S3 LS is what I'm showing the command, and it is showing me all the buckets that are right now present in my S3 service. Okay, so this is one way. So again, as a system admin, you can write a shell script, be it PowerShell, be it Bash, or whatever you are using. So you can write shell scripts with AWS commands in it, and that will get executed. So this is one way. And of course, for almost every service out there, the equivalent AWS CLI commands are there that you can use to create those resources, to update those resources, modify them, delete them, and things like that. Almost for every service out there, there are such the commands available you can use from the command line. Okay. Other than that, the third part is software development kits. So depending upon which tool you might be using, say for example, right now I'm demonstrating the Eclipse here. So as you can see, this is a sample code on your in front of your screens right now. Okay, this is a code for getting the object data from an S3 bucket. Now here, you can very easily see that I'm using a Java code actually. And for that matter, there are certain things which are AWS specific. So for example, I'm referring to the S3 client. I'm referring to the keys. I'm referring to the objects. I'm referring to the regions and so on in my code. So how this is possible? This is possible with the help of AWS software development kit available for Java. Similarly, if you are using maybe Python, there is this SDK called Boto 3 or Boto 4, which you can use to write a Python code to interact with AWS services and resources. Similarly, you will find a lot of SDKs available. Like there have been 3 recent additions, SDK for Kotlin, for Rust, and for Swift. Other than that, we have SDKs available for Go, Ruby, C++. So there's a long list of languages for which we have supporting SDKs available in AWS. Again, it's pretty straightforward. Go to the browser, search for AWS SDK, and there you go, SDK and programming toolkits for AWS. So you simply click on it, and you will find this landing page where you will have all the supported languages available, like Go, Java, JavaScript, .NET, Node.js, PHP, Python, Ruby, and so on. And for every relevant language, you will find a set of relevant resources available. Okay, so you can just go ahead and start using that. If you are a programmer or developer, you can start writing programs for your AWS based workloads. Okay, so great. So these are the 3 different ways, like programmatically using the command line interface and using the GUI or the management console. So this is how you can interact with AWS services. Okay, coming back to the slides once again. Let me, okay, Nivya has already answered the questions. Thanks, Nivya, for that. Now, again, on top of that, you also have a mobile app that you can download for both Android and iOS. You can download and have some kind of control over your resources from your mobile, right from out of your mobile. So you can just go ahead and use that as well in your for your AWS resources. So this is called AWS Management Console mobile app, which you can use to quickly and easily view the existing resources. Of course, it's not a full-fledged interface out there, but still it's very helpful with respect to viewing your billing details, your resources, various resources, and things like that. Okay, there's a question, is it mandatory to know programming to learn AWS? Not mandatory, Mohammed. It's not mandatory as such. So depending if you are, say, for example, a developer, I mean, you are in a developer role already, and then you want to leverage AWS services through programmatic interface, of course, you can do that. Or in that scenario, yes, knowledge of programming languages is a pretty good thing. But if you are in some other roles, say for example system admins, say for example security admins, maybe programming may not be really required out there. But yes, if you have exposure to some or experience with some languages, like say for example Python, that can definitely help you leverage a lot of things from AWS services. Okay, please tell us 4 ways of interaction with AWS. So, Shekhar, once again, I'll repeat that for you. Graphical user interface, that is you're using your management console, which is browser-based GUI. Second is your command line interface using the AWS CLI tool, which is available for different platforms, Linux, Mac, and Windows, all three. Then third one is using SDKs programmatically. So whichever programming language you may want to use, you can just download and configure the appropriate SDK for that. So SDK for Java, Python, Ruby, Go, whatever. And the last one is directly hitting the service endpoints, API endpoints, just like maybe using the tools like Postman or maybe using curl, CURL, curl. So you can directly uh, uh, invoke the API URL endpoints. Great. Other than that, AWS also supports to provide some toolkits for IDEs. So for example, again, here in my Eclipse, you will find this orange icon appearing here. And if I click on this drop down next to it, so you will find different choices, options available for working with AWS specific things. How do you get this toolkit? It's pretty straightforward. Again, depending upon which IDE you're using. So for example, in case of Eclipse, I can go to the Eclipse Marketplace, and I can install that. In the meantime, it is opening up. Let me also open my Visual Studio Code for all of you. Okay, so it is kind of, trying to prepare the list for Eclipse Marketplace. And once it is ready, I'll show you how you do that for Eclipse. And in the meantime, I have opened my Visual Studio. So from Visual Studio, if you go to extensions part, and here if you type AWS, so you will find this AWS toolkit thing available. So right now it is already installed on my machine, and hence it is showing me an uninstall option, but otherwise it will show you an install option. Okay, so you can just go ahead and you can click on install. Once done, the AWS toolkit for Visual Studio will be installed on your machines, and you can just go ahead and you can start working with that. So let me close this, and sorry. So once done, you can take a look at the extensions marketplace, or you can simply work with those extensions. Now coming back to the Eclipse part, here you will see that some updates are available. I'll update them later on, but for now I'll just type AWS here once again and enter the search button. And again, it will show you the AWS toolkit for Eclipse here. Since it is already installed, it is showing it as installed. Otherwise, it will simply prompt you to install it. Once done, you will get an icon like this available, an orange icon. And these other options will be available for interacting with AWS services, right? So again, different toolkits are available for Visual Studio Code, Visual Studio, Eclipse, IntelliJ IDEA, PyCharm, and so on. So for a lot of IDEs out there, different AWS toolkits are available that you can work with. Great. Okay, so coming back to slides. So this is what we have covered just now. Key takeaways from this part of the session. With a pay-as-you-go pricing, cloud service platform AWS delivers compute power, storage, database services, and various other resources. Regions and AZs are more highly available, fault-tolerant, and scalable than traditional data center infrastructures. AWS supports 3 different management interfaces to access your account: web-based management console, which is a GUI-based interface, then the CLI for various platforms, Linux, Mac, and Windows, and SDKs for supporting various programming languages, and AWS Toolkits for various IDEs today available for use. So these are the key takeaways up till now. Okay, let me take a few questions that are there. Does AWS recommend for an on-prem backup for AWS infra? Okay, so what I'm Karan Kumar, I'm understanding from your question is this a best practice as recommended by AWS? So again, you do not essentially require that, but just in case you want to be more, you want to play more secure, more safe, you feel that there is that kind of requirement, you can very well go ahead and do that. So you can anytime go ahead and you can leverage the hybrid deployment model of cloud computing. So again, AWS has services out there to support the hybrid setups, hybrid architecture. So that's totally up to you, your requirement. If you want to do it, AWS does not stop you from doing that. In fact, on the other hand, it has services that actually supports you in that. So you are most welcome to do that. When you say Mumbai region, does it mean all the AZs having multiple data centers are physically built in Mumbai geography? Yes, that's exactly how it is. So when we say Mumbai, so don't take it as Mumbai city as such. It may be somewhere, not exactly in Mumbai city, somewhere around Mumbai, nearby Mumbai. Could be 150 kilometers away from that or something like that. So not exactly maybe in Mumbai, somewhere around that. And since there are 3 availability zones, which mean 3 sets of physical data centers, so there could be nearby Mumbai. The way AWS is naming it, it is calling it as a Mumbai region. Very soon we are about to launch the Hyderabad region also in India. So India will have 2 AWS regions now. One is the Mumbai region, and another one is the Hyderabad region. Now, when we are saying Hyderabad region as such, we are not saying that the data centers are actually within the Hyderabad city. It may be around that also. Now, as a matter of fact, for security measures, due to security measures, nobody actually knows where these physical data centers actually are located or where the AZs are actually located, which physical location. Only the third party independent auditors who are auditing the AWS infrastructure, the resources, only they know, or the staff which is actually working in those data centers, they are aware of those physical locations. Even we as instructors, we do not know the physical locations, the actual physical locations of these data centers. Can you please explain edge locations networks? Yeah, definitely. So, Nisha, edge location, think of it like, as I mentioned previously, also a mini data center providing a very few of the services from AWS, stable. So like CloudFront, Route 53, Web Application Firewall, Shield, and Lambda at Edge. Now, what's the purpose of edge location? It is to provide the minimum latencies, the lowest possible latencies to the end users without deploying your whole infrastructure there. So, for example, CloudFront is a service which which is a content delivery network service. So you can put your content as close to the end user as possible, right? So that's the purpose of CloudFront. Second is, say for example, Route 53. So because Route 53 runs out of edge locations, the AWS officially claims 100% uptime SLA for that service. Because even if a few edge locations are down, your request may still be routed through the different available edge locations which are still up and running. The second benefit that you get out of the edge locations is you can increase you can kind of control the blast radius in case there are some attacks. So for example, if your content is being distributed through the edge locations, the effect of distributed denial of service attacks, DDoS attacks, can be minimized. And also on top of that, you are having services like WAF and Shield working on edge location, so that definitely helps you protect from these kind of DDoS attacks, cross-scripting attacks, and so on. So these are the benefits of edge location. So edge locations are also physically present out there, yes, of course. Okay, so I hope this looks good to all. Let me move to the next set of topic. Now that we understand the global infrastructure of AWS, we understand a little bit of security measures, we understand the different ways of interacting or interfacing with AWS services, how you start building your infrastructure. So the very first thing that comes to the mind is setting up some servers, because that is what we need, whether we want to set up an application server, web server, database server, or whatever kind of server we want to put in place. We need a machine, we need a server. So how do we do that on AWS? So in AWS, we refer to them as AWS Ec2 instances, and that is what we try to provision. What are the benefits of Amazon Ec2 instance? It provides you elasticity, control, flexibility. It's well integrated with other AWS services, reliable, secure, inexpensive, and easy to accomplish. So instead of going theoretically, let me open my browser here, and I'll straight away go to my management console where I had this Ec2. Quickly demonstrate how to launch, how to provision and use a server. So before I do that, let me show you that this jump host link that I have right now in place. This is also working like a web server to me. If I open this in another browser, let me use this public IP. And there you see, if I hit this IP, it shows me the output like on the response on the screen. Hello from this. So some kind of, a very, very basic level index.html, which is there, which is deployed, which is hosted on one of my machines. And this machine is also working as a web server for that matter. Okay. Now, things first, let's try to launch an instance. So when I'm using the word instance, essentially what I mean to say is a virtual server, a virtual machine. Okay. The first step is choosing your AMI or Amazon Machine Image. So what is an AMI? AMI is basically a template. The definition goes here itself. It's a template that contains the software configuration, OS, application, server, etc. that you want that are required to launch your instance. So what you intend to use your server for, your machine for? You want to treat it as a Linux server, as a Unix, as an Ubuntu server, as a Windows server, a Mac machine, whatever. So if you scroll down this list, you will find that there are so many options available. So there is Amazon Linux, Amazon Linux 2 with kernel 4.14, 5.10, Mac OS with different OS versions, and then RHEL, Linux 8, SUSE Linux Enterprise Server, Ubuntu Server, and so on. Microsoft Server, Windows Server 2019, 2016, and this list goes on and on. And if you see, you have a deep learning AMI available, which supports out of the box, which supports MX Net 18, TensorFlow, PyTorch, and so on. So these softwares will already be there for you to use. Great. So depending upon what your requirement of software is, OS is, you are going to select an appropriate AMI. Now, there is something called as AWS Marketplace, where you can find some AMIs customized for very specific use cases from our solution partners. And these kind of, are in contextual to infrastructure, software, DevOps, business applications, machine learning, IoT, industries. So lots and lots of options are available to choose an appropriate AMI. Going back to the AWS provided predefined AMIs. Now, certain AMIs are going to support both the x86 architecture and the ARM-based architecture, which means the different set of processors that you can use. So, for example, x86 will support the AMD and Intel processors, whereas the ARM architecture is going to support the Graviton series of processors, which are in-house processors from AWS. So let's go stick with x86 for now and click on this particular AMI. This next thing it will ask you to select is the hardware configuration. Okay, so you will find that this we refer to as instance type. So instance type basically is representing the hardware configuration that you want to set up for your machine. So right from one CPU to half a gig of RAM, this keeps on growing. You will find a combination of maybe 8 CPUs and 32 gigs of RAM, or maybe even hundreds of CPUs and uh, terabytes of RAM. So or hundreds of gigabytes of RAM. On top of that, it also shows you whether it is EBS optimized. So you get the storage optimization. So certain instances support that. And then what kind of network performance you can expect from the particular instance type that you have chosen. Okay. So again, there's a long list out there. As a matter of fact, right now you see we have selected all instance families, current generation. So if I click on this drop down, you will find that there are so many instance families available. Now, these different instance families have actually different use cases associated with them. So you will find instances which are appropriate for data learning kind of, machine learning kind of use cases, for graphics intensive use cases, for storage optimized use cases, and so on, or for memory optimized use cases, and so on. So I'll request Nivia to please share with the participants the instance type link so that they can refer to it for the classification of various families. Okay, so for our demo purpose, we will select T2.micro and click on next configure instance details. Now here it is asking me for certain configurations, like how many instances I want to launch for this purpose, the purchasing options, the network layout where I want to keep my instances. So we'll not bother about what is this VPC and what is the subnet. For now, we'll just select something and I'll put it in one of my subnets. So I'll select public subnet A and I'll assign it a public IP auto sign. I'll allow auto sign, and then we are good to go. So rest of the settings I'm not touching them. One important interesting one is that I'll definitely like to show you is the enable termination protection. So if you select this flag protect against accidental termination, this will help you to avoid any accidental termination of your instance. Termination means terminating an instance means that you are shutting it down and you are disposing it of, which means it's no more available for you to work with. So for your critical instances, you may not want any kind of even accidental termination. Forget about intentional. You may not want even the accidental termination. So this flag, enabling this flag, will help you to achieve that purpose. Great. Then we click on next, add storage, and now it based on what AMI you have selected, it is providing you a default root volume or a boot volume with some predefined size. You can modify the size if you want to. Then you can select the volume type that you want to associate, GP2, GP3. For all these 4 volumes, these are SSD based, as you can see. And then you have an option for magnetic as well. Now please remember, there are hard disk drive options also available for storage volumes, but you cannot use them as a boot volume. So for boot volume or the root volume, you only have choice of SSDs or magnetic. Again, if you want to make them encrypted, you can do that. If you want to keep them as it is, you can do that. If you want to add some more storage volumes with your instance, you can also do that. So for now, we are not going to do it. I'll simply remove this one. And then next, I'll click on add tags. So tags basically are for identification purpose. So you can identify your group, your resources based on some maybe workload, maybe some application, maybe some environment, and so on. So I'll simply go ahead and add a tag. We give it a name tag. We call it demo EC2. And click on next, configure security group. Security groups, think of security group like virtual firewalls, which will help you to allow, because by default everything is denied, all the input output traffic is denied. Sorry, all the incoming traffic is denied. So you will need to explicitly allow any incoming traffic that you want to your instance. So either you can create a new security group or you can select an existing security group. So how do you set what you want to allow? So for example, by default it is allowing the SSH traffic, which is on port 22, from all the hosts from the internet. I may not want to do that. I may want to define my own rules. So I click on this add rule, and I can go on clicking as many rules as I want. And I can specify the port range. So for example, I want to allow the HTTP, I want to allow the web traffic from port 80 and port 443. That is my HTTPS. Okay. Either I can do it this way, or I can select the name of the protocol from here. So I'll simply type HTTP here, and I'll type HTTPS here. And there it goes. This is where it is. So again, you can also define, restrict your traffic or allow your traffic based on the specific IP addresses if you want to. So this is how you can go ahead and you can create a new security group. Now, as a matter of fact, I do have a security group with me, which I'm calling BaseNet Web SG. So I'll select this BaseNet Web SG. And you can see it is allowing the HTTP traffic on port 80, 443, and port 22, that is SSH. If on the similar lines, if I select this BaseNet Web Win SG, which is specifically for Windows instances, here instead of SSH, I am using RDP. So I'm opening the port for RDP, that is 3389. Okay. Okay, let me go back to the BaseNet Web SG, and now I click on Review and Launch. Great. So this gives me a chance to review all my settings that I've done, and it is warning me that you have this open to the whole world, because I have opened SSH for all the IP addresses, but for demo purpose, that's fine. Let's go ahead. So now it is asking for a key pair. So what is key pair? It is basically public-private cryptographic key pair that I can use to protect secure my instances. So basically, only those machines, only those users who have the access to my private part of the key pair, they will be able to connect remotely to my machine. So the public part of my public-private key pairs will be saved in my remote machine, remote server, whereas the private part of it will be stored in the client machines or the local machines. So now that I do already have, there are three options: choose an existing one, create a new one, or proceed without a key pair. Now, in case you don't want to connect to your instances remotely, you can choose for proceed without a key pair. That is not required then. Now, since I want to connect remotely and I have some key pair with me, I'll select that and I acknowledge that I have access to that. Launch instances. Now, if everything goes fine, my instance should be launched. So I should see this message. Then I click on View Instances. And on my dashboard, you will find that demo Ec2 instance is also displayed in pending state. I'll try to refresh the status. And in a few minutes from now, it should be the status should be changed to running. Now, leaving this aside, let's say that we have this jump host Linux already deployed, provision up and running. I want to remotely connect to this. I'll right click here, click on this connect option, and there I have some options to connect. So this one, the first one that comes, Ec2 Instance Connect, that allows me to connect to my remote machine using the browser as my client. So I don't need any specific software there. I'm just going to connect using my browser. And there you see, I'm now connected to my remote machine. Okay. If I simply run ls -n here, so you see I have just one folder coming up and one file here. It is there, AWS CLIV2.zip. If I go to AWS folder and do an ls here, okay. So basically now I'm connected to a remote machine, a remote Linux machine, and I can use it pretty much like any other server, any other Linux box. Just go ahead, install whatever you want to, uninstall whatever you want to. And as a matter of fact, let me see if I can do that. Systemctl status httpd. So you see this httpd server, Apache web server, is active and running. So this is also supporting I'm using this server as a web server as well, right? So again, the idea here is with this demo is that you can, once you launch an Ec2 instance, you can pretty much go and install and configure any softwares and use it for any purposes that you want. Maybe a database server, maybe a web server, a security server, whatever, application server, and things like that. Nice. And yeah, so that's how we remotely connect to our machine. Now again, if I have to connect from my local machine using SSH, I'll copy this command SSH, and if you see, it is mentioning the key pair that we set up there. So now I'm going to go to my local console. We'll copy this command and paste it here. But for that, first I'll go to another folder called AWS key pairs, because this is where I have saved my key pair that I need, KP Singapore official PEM, as you can see here. And now I'm going to paste that SSH command and connect to my remote machine. So I say yes, and there you see I'm connected to my remote machine. If I do again an ls here, so you'll find two entries here, AWS and this file. Just to verify I'm on the same machine, do an ls here. Okay, so the same set of contents is appearing. So this is how you remotely connect to your EC2 instance. So it is a Linux box, I'm using SSH. Had it been a Windows box, I'll be using the RDP. Okay, so yeah, that's how it looks. Once I'm done working with my remote machine, I'll just exit out of it and come back to my local environment. Okay, so a few things that you need to remember. Number one, you need to define the AMI, which is Amazon Machine Image, which is nothing but a template for the operating system, the application software, the other software that you intend to run on your remote on your instances, Ec2 instances or virtual servers. Number two, instance type, that is the hardware configuration, the capacity that you want to ensure for your EC2 instances. So how much memory, how much CPU, the network bandwidth, the EBS volume, the EBS optimization, the storage, space, and things like that. So all that can be done with the configuration, and then setting up the firewalls, which means the security groups, which means what kind of traffic can interact with your launched servers. So be it HTTP, HTTPS, be it FTP, or any other, even custom traffic that you may want to allow to enter your EC2 instance. So great. Okay, there's a question. If I have one question, if I need to install a custom software into my cloud instance, how to do that? If you can share a help. Okay, so Ritesh, you can pretty much install any software like you would be doing. The only thing is you would be needing to download the installable artifact of that software, and then again follow the normal steps that you do. So again, just like your local machine, first of all, you download the software, the software package, the installer package, and then you execute that. Same thing is going to happen with your remote instances as well. Now, again, maybe it's confusing for you right now because I am demonstrating using the Linux instance, but let me also, for that matter, show you with my Windows instance. So what I'll do is I'll simply start my Windows instance, which is in stop state right now. And then I'll remotely connect to this instance. So I'll just copy the public IP address. And from my local machine, that's a Windows machine, so I'll be opening the RDP tool. And this is how it looks like. I'll paste the public IP address, click on connect. And here I'm going to click on more options, use different account. Okay, and then I'll connect it. And there you see, I'm connected to my Windows machine. Now this is a remote Windows machine, remote Windows server. So now you can see I have already downloaded and installed the Visual Studio Code inside our Eclipse, the Brave browser, and things like that. So again, that's pretty the similar way you are going to work with your local machines. Okay. Okay, great. Welcome. So let me shut down this now. And that goes. Okay, so that is how you work with the remote instances. Now, for that matter, let me again set the status to stop. Now, if you remember that with our new instance, we tried to set up a flag. If you remember that. So now what's the impact of that flag? Now let's say I'm done using my remote EC2 instance. I don't want it anymore with me. I want to terminate that. Or maybe somebody comes and tries to accidentally terminate that. So I right click here and I click on terminate instance. Click on the terminate button. So it says fail to terminate the instance. Why? Because we need to modify its disable API termination instance. Which means because since I turned that flag on, it is not going to terminate it. So first of all, I'll need to change that. I'll go to instance settings. I'll change the termination protection, disable that, save it. And now if I try to terminate it once again, this should be able to do it. So now you see it is successfully terminated. Okay. Now the status you see is changed to shutting down. In a while, this will be the status will change to terminated. Now once it has changed to terminated, the instance still keeps on showing for some time on this list on the dashboard. After some time, say around 5 to 10 minutes, this will disappear from your list. Okay, which means the resource is now gone. Nice. So that is how you can work with instances or servers. Great. So I hope that makes sense to all. So time for a quick knowledge check. What are the benefits of using Amazon EC2 instances compared to physical servers in your infrastructure? So basically, what are the benefits? You can look here. So number one, they are resizable, which means you can vertically scale them up or down whenever you want. So you can change their virtual CPUs. I mean, so once you have selected an instance type, say for example T2.micro, you cannot go and change the hardware configuration for that very instance. You cannot change its CPU, you cannot change its memory, but rather what you can do is you can change the instance type itself for that particular instance. So maybe you started with a T2.micro. Later on, you realize that maybe it's not very much appropriate. You may want to increase the capacity, hardware capacity. So you go ahead and you change the instance type. You may be from T2.micro, you go to T2. Extra large. So now you get 4 CPUs maybe or 8 CPUs and 16 gigs of RAM. So that is how you can implement the resizing of your instances. But you cannot change the hardware configuration for the same instance type. So if you say that, okay, I want to work with T2.micro, but rather than 1 gig of RAM, I want 2 gig of RAM. No, that's not possible. Okay. So resizable in the sense you can go ahead and you can change the instance type of your instances. Then they support pay only for the capacity you use, which means if you are provisioning a T2.micro, you are only going to pay for T2.micro. If you are using M6.large, maybe you are going to pay for M6.large. So whatever resources you are trying to consume, you are going to pay as you go based on those resources. The ability to have different storage requirements. So again, the EC2 instances give you the flexibility of choosing your storage volume types, the amount of storage you need, the encryption, if you may want to enable encryption on that storage, and things like that. Also, for the purpose of those workloads where you need very high input output per second, high throughput, you can opt for the provisioned IOPS kind of volumes. For those kind of workloads where you do not need much high throughput or very fast IOPS, you may go for the HDD solutions also. So there are two HDD based solutions. One is called the throughput optimized HDD and one is called the cold HDD. So cold HDD again, where you may not have very frequent read write operations, you can go for cold HDD also at a very low cost. So all these options are available with your EC2 instances. So the options A, B, and E are the correct options here in this scenario. Now we have seen in one of the steps, the EC2 instances allowed us to set up the storage. By default, it created a root or a boot volume for us based on what AMI we have selected. On top of that, you are free to add multiple storage options to your instance. Now, this you can do with the help of something called the service called Elastic Block Store. Now, where do you get the Elastic Block Store on your web management console? Of course, and again, please remember, you can do all these things through management console, through CLI, or through SDK. So that's absolutely fine and doable. Now, on the same EC2 instance screen, if you scroll down, you will find this section called, on the left panel, Elastic Block Store. If you click on this volumes, it will show you the already present volumes. So as you can see, there are two volumes associated with my two instances. You can go ahead and you can create a volume if you want to. So creating a volume is just like, it is analogous to purchasing a storage device from the market. So maybe I'm purchasing a pen drive or maybe an external hard drive, which later on I may want to attach to one of my machines. So in volume settings, again, you get the option for the SSDs or the magnetic tapes or the HDD, which is cold HDD and throughput optimized. So these are the 7 options available to you. Then how much storage amount do you need? Storage volume do you need? Okay. So minimum is 1 gigs and maximum is 16 terabytes. Okay. And this is the IOPS that it is going to support, the GP2 that you have selected, general purpose GP2, and which zone you want to provision this resource. Now, please remember, you should select a zone here, the same zone in which your instance is running, with which you want to attach this volume. So both your volume and your EC2 instance that you want to attach this volume to, they should be in the same availability zone. Then for snapshot, I don't want to create this volume from a snapshot. I want to create it afresh. Fine. If I want to encrypt this volume, I can do that. If I want to provide it a tag, I can also do that. So let's again give it a name tag, and let's call it as demo EBS. Great, and then I click on create volume. So now the volume gets created in my Singapore region in the availability zone 1A. Now if I want to attach this volume to my instances, I'll just select it probably in the actions drop down. I'll go ahead and I'll have these options available. So here you see attach volume. Right now it is disabled. Just give me a second. Should be enabled any point now. Yeah, so now you see the option attach volume is enabled. I click this. Now only those instances which are in this availability zone, AP Southeast 1A, these will be the instances with which I can attach this volume. So there are two options, jump host win or jump host claim. Depending upon which instance I want to attach this volume to, I'll attach it. So let me attach it with my Windows instance for a moment, and then click on attach volume. Now what I'll do is, once again, I'll go back to my instances. Once again, I'll start my Windows instance. because it was stopped for now. Now it doesn't matter whether your instance is up and running or it is stopped. Once you attach the volume, it gets attached. Let me click on my Windows instance, start it once again, and once again I'll reconnect to my remote Windows instance. And there goes my RDP. Okay, so I'll sign in to that. Okay, so now I'm logging into my Windows machine, remote Windows machine. Now here you will find, if I open the File Explorer, right now it shows me a C drive, which is of 30 gigs, right? Oh, sorry, which is of 100 gigs. Now that is something which was already there in my for my Ec2 instance. So let me go back to the volume screen here, and you will find with the Windows 100 gigs is already attached. I have created another volume of 100 gigs that I have attached to my Windows. So now it is like I have attached a newly brought external storage to my laptop, but it is not usable right now. Why? Because I have not set up any file formatting or things like that. So for that purpose, what I'll do is I'll open the disk utility for that, and I'll make it usable for my Windows machine. So it has detected that, okay, I have a new device attached to it. I'll click OK, and there you see one set of storage volume, it is showing formatted with NTFS, the other one is unallocated. So this is the new one. I'll go ahead and I'll click on new simple volume. Now what I'm doing here right now is has nothing to do with AWS or EBS. This is all operating system specific. So for Linux machines, you will have its own way of mounting the device and making it usable. In Windows, I'm doing it this way. So I'm creating a usable volume now. Okay, done that. Next, finish. So once that is done, you see now I have two volumes here, C and D. And if I go to my File Explorer, here also you will find the new volume display. You can go ahead and you can start using it just like any other volume. So let's call it a test folder, and within this test folder, maybe I create a new file. Okay, so this is just like working normally with any other storage device. Great. Now, once you are done working with your additional storage volume, you can just go ahead and you can unmount it, or you can detach it from your machine. So let's try and do that. I'll go back to my volumes. I'll select demo EBS, right click and detach the volume. Now please remember, from cost point of view, simply detaching the volume does not mean you're not going to incur any cost on your volume. Till the time the volume is with you, you will be charged for that. You will be billed for that. So if you do not want to pay anything for volume, you should go ahead and delete that volume. Now that I have detached this EBS volume, I can attach it to any other Windows instance or again. But for now, you see that this volume has also disappeared from my remote machine. So now I'm only left with the this volume, which is drive C. Great. So now what I'll do is, and here also in the disk utility, you see that I do not have that volume. Okay, great. So now I can go ahead and I can stop my instance. Oh, sorry, this is the, yeah, I can go ahead and I can stop my instance. And then I will also delete the demo EBS volume because I do not need anymore. So I'm going to go ahead and I'm going to delete this volume. Okay, so it contains instances. So coming back to slides once again. So what we provide you is persistent block storage for instances protected through Replication, different drive types are available to choose from. Scale up or down in minutes, so you can change the size of your storage volumes. Pay for only what you provision, which means once you have provisioned a storage volume of 100 gigs, depending upon what type it is using, a hard disk, SSD, different types of SSD, you will be charged for that. And please remember, whether you have attached it with any instance or not, the moment you provision your storage volume, EBS volume, the billing starts for that. Okay, so in case you don't want to be billed for that, you have to delete that volume. Please, simply detaching it does not mean you will not be charged for that. Snapshot functionality, so you can take snapshots of your EBS volumes, and encryption is also available. Okay, another storage option available is your S3 service. So what exactly is S3? It's again a storage service from AWS. So data is stored as objects within buckets. Sometimes we also refer to as cloud storage. Sometimes some people also refer to as blob storage. Basically, it's storage in the form of objects. So whatever you are going to store there, some files, some data, that will be stored as an object. Now to understand S3 in that term, let me quickly go back to my whiteboarding. So think of S3 service. So there are two components to it. One is called the buckets and one is called the objects. So think of buckets like some containers which are going to contain some objects. Okay, and what are these objects? You can refer to them as files, as some data with some. Okay, so essentially, if I have to speak technically, your buckets is like a hash table in the form of key value pair, where key is the name of the file and value is the content of the file, or value could be some data as well, referred to by some key. So this is how technically the S3 service looks like. So again, S3 service has buckets and objects in it. The buckets are think of buckets like containers, which are going to hold the objects in them. What are objects? Objects are nothing but a form of key value pair. So name of the object is the key, and value of the object is the content of the object is the value part. Great. So this is essentially what S3 looks like. So the data is stored as objects within the buckets. Then it literally provides you unlimited storage, which means how many objects you can store in a bucket. That is absolutely unlimited. But there is a restriction that a single object should be less than or equal to 5 TB. It cannot be greater than 5 TB, a single object. But how many such objects can you put in a bucket? That is absolutely unlimited. Okay, so S3 can provide you unlimited storage. It provides you 11 nines of durability, which means the integrity of your data will be intact up to the 11 nines. And you get to control a granular access to your buckets and objects with the help of IAM policies. Now, when we come to the IAM part, we'll talk about that. So you can secure your buckets and objects at a very fine granular level. What are the common use case scenarios for S3? You can use it for backup and storage purpose, application hosting purpose, media hosting purpose, software delivery purpose. So essentially, store once and distribute multiple times. That is the bottom line. So you want to store a content, maybe some PDF file, maybe some media file, maybe some image file, and then let it be distributed to multiple users out there over the internet. So that essentially is the essential use case. Now, one interesting use case here for S3 is hosting static websites without being concerned about setting up any web servers or any such things, configuring them. You can simply go ahead, you can save your project folder into S3, one of your S3 buckets, and explore it and use it as a static website hosting purpose. Now, there are different storage classes available in S3. Now, before I start with this, let me quickly show you on my management console also how S3 looks like or how do you work with that. So I will simply type S3 here on the search bar and go to that S3 dashboard. Okay, so here you see there is a long list of buckets in my account already. I'll just go ahead and try to create a bucket. So I'll click on this create bucket. Now there's one important thing to be aware about bucket names. Now again, there is a complete naming convention for the bucket you can get from this link, which is just below this text box. So I'll request all of you, whenever you are dealing with that, please try to explore this naming convention. But one important thing that you should always remember is that bucket name has to be universally unique, which means if anyone, anywhere in this world, in any AWS account, if they have used a bucket name, you will not be able to reuse it in your account. So for example, if I try to create a bucket by the name Aman, and no matter which region I'm creating it, so for example, I'm creating it in, say for example, Singapore right now by default. If I click on create bucket, it gives me this error. Bucket with the same name already exists. Now, as a matter of fact, if you go to my list of buckets, you will not find any bucket by the name Aman. Somebody somewhere in this world, in their AWS account, they have created a bucket by the name Aman, and therefore I cannot use the same name for one of my buckets. So please remember, it has to be globally unique, or what we call it as DNS compliant. So your bucket name has to be DNS compliant. Okay, so let me select some bucket name. Let me call it APSM demo bucket. And now I'm creating it in Singapore region. Now, although you will find that when you are dealing with S3, it is a global service, but when you are creating a bucket, it explicitly asks you to provide the region in which you want to create the bucket. Now, there is again the three factors working behind that. If you remember the four factors we talked about selecting a region. So out of that, one factor does not apply here, which is the service availability, because S3 service is available across all the regions, AWS regions. So that factor can be eliminated straight away. The three remaining factors, your data governance and legal requirements, proximity to end users, and the cost. So these three factors are still playing role. So please remember that S3 is a storage service. You are going to store some data there. So it is very important to realize that what compliance or legal requirements you need to apply, your application need to apply. So you will be creating an S3 bucket appropriately to store the data, the relevant data. Okay, and that is why it is important for customers to select a region where their S3 bucket will actually be created. Once that has been created, it becomes a global service. Okay. Second thing, with say your multiple regions are complying, are allowing you to comply with the data governance compliance and legal requirements. Now you would definitely prefer to be as close to the end user as possible. So that will be another factor. And of course, out of those regions, you will be preferring a region which is allowing you lower costs. So that is why AWS or BS3 allows you to select a region for creating your buckets. Okay, so now that's it. If we click on create bucket, and this bucket name is unique, this bucket should be created. So now if I scroll down, APSM demo bucket should be there, and there it is. Right, so this is the one that we have created just now, February 7. Now, as a matter of fact, this bucket should be empty. So I'm going to upload some content to it. I'll click on upload. I can either add files or add folder. I'll click on file. And at random, I'll select some file. I'll maybe select, say for example, okay. view that job search CSV. So from that I'm going to select, and then I'm going to click on upload, and that gets uploaded. Now again, all these activities, for these activities you have a parallel CLI or SDK interfaces as well. So say for example, you can say MB, which is make bucket command, and provide the bucket name. Similarly, you can say remove bucket RB and then remove the bucket. You can sync or you can copy the files from your local storage to your S3 storage. Great. So now what you see is it has been successfully uploaded. I'll close this. So now in my demo bucket, I have one object. Okay, so that is how it works. Now please remember, AWS S3 has different storage classes to it. What is the purpose of those storage classes? Why do we need it? So let's take a quick look at that. So in your storage classes, you have standard, infrequent access or standard IA as it is commonly known. You have one zone infrequent access. You have something called as Glacier. You have Glacier deep archive. You have intelligent tiering. So these are some storage classes available. Now, what's the use cases for these storage classes, and what's the purpose of having different storage classes? Now, by default, whenever you're dealing with S3, you are actually working with the standard storage class. Now, standard storage class among all of these have the highest storage cost, but it has the lowest retrieval cost. So whenever you're going to retrieve the data from a standard storage class, that will be the lowest cost. Okay. When you go to the standard infrequent access, as the name suggests, standard infrequent access. So it is going to have a lower storage cost as compared to standard, but will have higher retrieval cost. So for those use cases where the data may not be very frequently accessed, it is a good use case to store that data in the standard IU, because that way you will be able to save some money. One zone IU, infrequent access. So as the name suggests, one zone. Now by default, your standard and standard IA, whenever you are going to store some data, that will internally be automatically replicated to 3 availability zones. Automatically, you are not going to pay anything extra for that. So that's an inherent feature of S3. So which means in case one AZ goes down, your data will still be accessible from the other 2 availability zones. In case of one zone IA, your data does not automatically get replicated to multiple AZ internally. It simply remains in one AZ. Now, of course, you can realize that the storage cost is going to be further lesser than the above 2, but the risk is that your data you may lose your data. There will be a data loss in case that availability zone goes down. So for those kind of data, which may not be very critical or which may be recreated, reproduced, that kind of data you can store in one zone IA and hence reducing your cost. Okay, but please remember, if you have critical data, you are not going to store that in one zone IA. Only that data which may not be very critical, you can afford to lose it, or there is a mechanism you can regenerate that data, reproduce that data. Only that data should go to one zone IA. Then we have Glacier and Glacier Deep Archive, which allows you for archival kind of use cases, where you may want to archive some data, keep data for longer periods, which is not accessible frequently, or which is accessible very rarely. So maybe you want to put some data for the archival purposes, and you will be retrieving it only at the times when some audit is required, or maybe there are some legal requirements. So that kind of data with very, very low storage cost, you can put that in Glacier or Glacier Deep Archive. Then comes intelligent tiering. Now, sometimes the access pattern or the retrieval pattern of some data may not be predictable. So you do not know beforehand whether this kind of data will be accessed frequently or less frequently. So it is better to put that kind of data in intelligent tiering. Depending upon the access pattern, depending upon the retrieval pattern, intelligent tiering will put that data into the frequently accessed class or the less frequently accessed class. So that way, based on some machine learning algorithms, it will help you to reduce your cost based on the retrieval patterns, based on the access patterns. Now, so all these storage classes, they'll help you to further manage your costs with respect to storage and retrieval patterns. So we need some other options out there which will allow us to implement high availability, fault tolerance, and so on, reliability. So first of all, what we need is we need to monitor our AWS resources. How do you do that? So CPU utilization goes beyond. If you find that your CPU utilization is going below 30% or 20%, you may want to unprovision or you may want to dispose of an additional EC2 instance. So these kind of things you can achieve with the help of CloudWatch alarms. So how exactly the CloudWatch works? So any supported AWS resources, they can send their default metrics to the CloudWatch, or CloudWatch can keep a track of those default metrics. On top of that, it can also keep a track of the custom metrics from your application specific metrics, and can show you statistics through the dashboards. You can create custom dashboards as well. On top of that, you can also set up the CloudWatch alarms based on those metrics, maybe a single metrics, maybe multiple metrics. And these alarms, when triggered, when raised, can help you to perform certain actions, like maybe trigger the auto scaling policies, or maybe send SNS email notifications or SMS messages to the respective persons or the authorities. So that is how overall the CloudWatch works and helps you to monitor your applications. So what are the benefits of using CloudWatch? You can access all your metrics from a single platform, maintain visibility across all your applications, infrastructure, and services. It can reduce the mean time to resolution, or MTTR, in case something goes down, and also help you to improve the total cost of ownership. You can use it to drive insights to optimize the applications and operational resources. So, for example, what are the, if the resources are performing well, if I need those resources, if I need to provision more resources, if I need to reduce the number of resources, so all that thing can be inferred from your CloudWatch metrics. And of course, the CloudWatch metrics As far as the pricing is concerned, it is pay as you go. CloudWatch metrics also helps you to CloudWatch also helps you to maintain logs, something called as CloudWatch logs. So you can centrally manage the logs from your applications, from your various AWS services at a centralized place. Further, you may want to stream those logs to maybe save them for longer purposes to S3 buckets. Now, one important thing and one very, very important benefit that we looked upon initially when we started the session was scaling, or don't worry about the capacity. So you want to manage the demand efficiently, and that is where the real advantage or the real benefit of cloud platform comes. So why does scaling matter? You will find, let's say this is a sample, demand graph for some application, which is like, say for example, a simple office application for booking the video conference room. So what you are seeing is that, of course, on a Sunday it is very, very low. Monday it kind of becomes a little bit higher. Tuesday a little bit more higher than Monday. Wednesday that goes to peak, and then starts coming down Thursday, Friday, and eventually Saturday, and then again it is the lowest once again on Sunday. So assuming that this is a demand pattern for that application, the video application. In normal use case and conventional use case, you may want to either achieve this load, or you may decide to go with an average load. What's going to happen is, if you go with the peak demand load in a conventional setup, you are going to end up with underutilized or unutilized capacity for most of the days, which means you are overspending. And if you try to go with maybe, say, the average load, then you run the risk of burning out your resources at the peak demand, right? Now, that is a very usual scenario when it comes to the conventional setups or on-prem setups. But when it comes to the cloud, or AWS cloud for that matter, you get this service like Ec2 Auto Scaling, which can adjust the capacity as needed. So either you can scale out for spikes, or you can scale in during off-peak. You can also replace unhealthy instances, and you can pay only for what you use. Now, effectively what we are talking of the Ec2 Auto Scaling service here, along with maybe ELB or Elastic Load Balancing. Now, again, it's pretty straightforward. And where do you find these services? So if I go to the management console once again, to the Ec2 Instance dashboard, you scroll down the left navigation bar, and you will find two sections: load balancing and auto scaling. So this is where you set up the auto scaling configurations and the load balancing configurations. So the benefit you are getting is that you see that you do not have to in present decide for the future, and let auto scaling and load balancers play a role for effectively and efficiently providing you provisioning resources as and when required on demand. So that thing is what you can achieve, and that is where the scaling also matters. Right. So dynamic scaling with Amazon Ec2 Auto Scaling, you can follow the demand curve for your application. You can select a load metric for your application, provide that load metric to the CloudWatch. So you can use a conditional and/or schedule, and you can use that with CloudWatch optionally. You can also define certain boundaries for your Ec2 Auto Scaling as well. So maximum number of instances that you want your Ec2 Auto Scaling to provision, and minimum number of instances you want to keep running. So even though auto scaling can keep on provisioning the instances or keep on reducing the instances, but still you want to define a boundary, a maximum and a minimum number of instances. So that is also what you can define with your Ec2 Auto Scaling. Let's say you started with this average demand with 6 instances, and now when the demand is high, you will allow the auto scaling Ec2 Auto Scaling group to provision more instances, but the maximum it can provision is total number of 10. And when you when the more instances are not required, when the demand is low, you can remove the additional instances, but still the minimum number of instances you want to keep on running is 2, so that you can specify in the minimum capacity. So that way you can also control the minimum and maximum number of instances. On top of that, you can also replace any impaired Amazon EC2 instances without any manual intervention. So you can define the configurations, the properties, which will allow the EC2 auto scaling to automatically remove or replace the unhealthy instances with the healthy one. So even that use case is achievable. Load balancing, again, elastic load balancing is a service which will help you manage your traffic load. So the purpose of load balancing is to equally distribute the number of requests that are coming to different EC2 instances behind the scene, which will be placed in the target group. That allows you to achieve high availability, health checks, SSL TLS termination, and operational monitoring. So again, to understand load balancing, it's pretty simple. If I have to set up an analogy, think of a hotel reception where some customers are flying in, they are checking in. Maybe there is just one receptionist on any normal day, but when it's come to the some festive days, some special days where you are expecting more number of guests, of course you will put in place more than one receptionist, maybe two, maybe three, and the workload will be divided. The traffic load will be divided equally among those resources. So that's the same purpose here for elastic load balancing. So it kind of allows you to set up multiple instances in the target group, and any incoming requests being distributed to those behind the scene instances and let them handle the load equally. And in case if one of the instances is unhealthy or goes down, that can be replaced with the help of auto scaling group. And in the meantime, the load balancer will make sure that no new requests go to that unhealthy instance, and rather the load is distributed among the remaining healthy instances. So that is where the load balancer, ELB load balancer service plays its role. So this is an example of application load balancer. In AWS, we have today we have four different types of load balancers. So first is ALB, application load balancer. Then we have network load balancer. Then we have classic load balancer. Now this is a more legacy kind of load balancer, right from the very initial days. Today we do not recommend or promote this load balancer to be used by our new customers. We are maintaining it for the back track purposes, and we very much recommend the use of ALB and NLB today. There is yet another one which is called the gateway load balancer. So this is also one of the newest load balancers which is there. The purpose is different. So initially, so essentially, as a developer, you will be working mostly with your ALBs and NLBs. Now here is another good example of application load balancer ALB, that it can also support the URL based or the path based routing. So for example, if you have some URL called mylib.com, and then this mylib.com is coming with images as a prefix, then those requests will go to this particular set of applications. If it is coming with /API, then it will go to these particular set of servers. If it is coming with the prefix /data, then it goes to this particular set of application servers. So you can distribute your requests based on the path that is being specified on the URL from the client side. So even that is possible with the help of application load balancer. So these are certain advantages of using the load balancer. Network load balancer provides you a very high level of throughput. So probably millions of requests per second that you can distribute to the underlying target instances. Great. So with that knowledge, let's take a quick round of knowledge check. Please put your responses on the questions panel where you have been asking all those queries, and we are replying, NEB is replying with our answers. The same panel you will be using for this response. So knowledge check, you have an application composed of individual services. You need to route a request to a service based on the content of the request. What type of load balancer should you use? So your options are A, B, C, D. Out of these, please select any one choice. Okay. Okay, great to see a lot of people are responding with C as their preferred option, which actually is the correct answer. So as I mentioned, application load balancer provides you an additional advantage that you can use it for path-based routing. So which means, as the question says, you need to route a request to service based on the content of the request. So that can be achieved with the help of application load balancer. Very nice, very nice. There were questions before these responses started. The question was, what is the difference between CloudWatch and CloudTrail? So CloudWatch, of course, we have seen that provides you a lot of features, not just logging, but many other features. So that's one difference. When it comes to the logging part, both CloudWatch and CloudTrails allow you to maintain logs. Now, whereas CloudWatch is allowing you to maintain your service logs or the application logs, CloudTrail has absolutely different purpose. So CloudTrail maintains any logs of the request response that you are dealing with the AWS services. For example, no matter which interface you are using, so maybe you are using the management console, you are using CLI or using SDK, or maybe you are making a direct invocation, API invocation. All these interfaces actually lead to this API invocation, API request invocation behind the scene. And then from here, the request is sent to the appropriate AWS services, and the responses are sent back as well. Now, AWS CloudTrail keeps a track of all the requests that you are making, the API requests, and all the responses of those API requests. So all this is being tracked in the CloudTrail logs for all the AWS services. Okay, so which means if some incident, some security incident happens in your organization, say for example, some EC2 instances terminated by someone. So AWS CloudTrail logs will help you identify like who made the request, from where the request was made, when this request was made, what was requested, and what was the response from that API. So whether the instance was stopped, whether the instance was restarted, whether it did stop, whether it did terminate, and so on. So all these API level events can be logged or are logged in CloudTrail. So CloudTrail logs help you with the audits and to deal with any incident response mechanism strategies for your AWS resources. Okay, great. So if you are talking about the question is the log will have the response data as is. So if you're talking in terms of CloudTrail, yes, there will be response data. Now, when you say as is, I mean, there are certain points, there are certain fields that it is going to capture for you. If you want to customize that, you can customize that. But of course, there are certain default fields it automatically captures for you. So yes, that's how it is. You're welcome, Dinesh. Okay, now let's talk about another set of services called the database services. So you have the option of DIY versus AWS database services. So DIY is essentially do it yourself. So which means, of course, you can provision an EC2 instance. You can bring your own maybe MySQL server software, your SQL Server software, Oracle software, whatever, you can install that on your Ec2 instance server and use it as a database server. Of course, nobody is stopping you from doing that. Only thing is that you need to take care of all the high availability, fault tolerance, and all that stuff on your own, the security patches, the database update patches, everything. So that will be your responsibility. But you get the total control in that scenario. But of course, this is one option. Another option is where you may not want to involve too many, database experts, or you do not have that leverage, you do not have that luxury to employ the DBA experts in your team. In those kind of scenarios, you can go with the out-of-the-box solutions from AWS, like the RDS or DynamoDB. So RDS, the relational database service, which is supports 6 database engines. So these are MySQL, MariaDB, PostgreSQL, and then Microsoft SQL Server and Oracle. On top of that, the 6th engine, which is indigenous engine, is called Aurora, Amazon Aurora, which again is compliant with MySQL and PostgreSQL. So there are 2 flavors in that. So when you are using the databases on Amazon EC2, you have the operating system level access, and you need you'll go for that when you need features of specific application. For AWS database services, you get the ease of setup, manage, and maintenance because you do not need to do absolutely anything around that. It's a push button, high availability option availability, focus on performance, and you get infrastructure out of the box. So these are the benefits using AWS database services. And as I mentioned, these are the 6 DB engines that are supported by RDS service. It makes it easy to set up, operate, and scale a relational database in the cloud. So the advantages that you get are like it is easily scalable, automatic software patching is available, automated backups you can take, and database snapshots. You can also take that point-in-time snapshots. Then it supports multi-AZ deployment. We'll talk about that in a moment. Multi-AZ deployment, what is this and what is the benefit you get out of it? Automatic host replacement and encryption at rest and in transit. So, what is multi-AZ deployment and how is it beneficial? Consider a scenario once again. I'll go to my. So, let's say if this is a regular arrangement where this is your front end, let's call it FE, this is your backend, some database, some application servers, and then it is interacting with your database. So here you are performing some regular CRUD operations. Now, maybe you have multiple instances of your front end or web servers, you have multiple instances of your application servers. So definitely for these things, you do not have any single point of failure. But when it comes to the database, there definitely is a single point of failure. Now, usually how you handle this scenario, you create another replica of this, and you make sure that these 2 database instances are in sync real time. And whenever this instance goes down, you bring up the standby instance as the primary instance and start working. But in your on-prem setup, usually you have to do this manually. Now in RDS, AWS RDS service, Amazon RDS service, you simply need to take an option called multi-AZ, or let's call it multi-AZ in short, or multiple availability zones. So just by clicking that, AWS RDS is going to automatically deploy another replica of the database server that you are configuring, and will set up automatically a real synchronization, data synchronization in real time between the primary database and the standby database it is creating in another availability zone. Now, whenever an AZ goes down, where you have the primary database or something happens to this primary database, it's not able to fulfill your request, AWS is automatically going to promote this standby database in another availability zone as a primary database, and the users will not observe any significant downtimes, and your application workloads will be up and running. So that's the benefit of having multi-AZ, and that this whole thing will happen automatically. You as a consumer do not need to do anything except for checking this flag that you need multi-AZ. Of course, it will cost you more as compared to a single database. But again, the advantage you get is the automated sync up and replication and setting up of a standby server, database server, which can be promoted again automatically to work as a primary server in case of any downtime, in case of any errors with the primary server. That is what is the multi-AZ deployment helps you with. Now again, we saw that there is a special indigenous engine called database engine called Aurora. So what is that exactly? It's an enterprise class relational database that is indigenous DB engine from Amazon. It is compatible to both MySQL and PostgreSQL. So there are two flavors to it. It's up to you which one you want to go for. Provides you up to 5 times faster throughput than standard MySQL database and up to 3 times faster throughput than the standard PostgreSQL database. And provides you a feature of continuous backup to Amazon S3 and also supports up to 15 low latency read replicas. So these are some of the benefits you get out of using the Aurora. Okay. Okay, so I'll just give you a quick idea of how does scaling of relational database work. Okay, Nivea has already shared a document around that. Yeah, so this link actually helps you to understand both the horizontal and vertical scaling in terms of the RDS. Great, so Nivea is answering most of the questions out there. Great. Thank you for that, Nivea. Multi-AZ sync will be in the same region. Yes, Shekhar, it will be in the same region as the name suggests, multi-AZ. So it has to be in the same region. Great. Now, other than the relational database services, Amazon offers you a NoSQL database solution or a service out of the box, and which is called Amazon DynamoDB, which is very, very fast and flexible. It's a fully managed AWS service, which means you as a customer, you do not need to bother about any machines first to set it up, the RAM, the CPU, nothing like that. And behind the scene, they are making use of high-speed SSD devices storage volumes. So, which means you can expect a very, very good throughput from the DynamoDB. Then, this is very, very suitable for any low latency queries and provides you fine-grained access control on top of regional and global options. Now, let me quickly walk you through the DynamoDB part of it. I'll go to my management console and I'll go to the DynamoDB service. Come on. Not sure what's going wrong with my account. I hope I'm not shown a pink slip today. No worries. Come on, not a good day, I hope. Okay. Anyways, DynamoDB allows you to implement a NoSQL solution using the AWS resources. So basically, what you will see when you go to the DynamoDB console, somehow I'm not able to do that. I'm really sorry about that. Let me use my whiteboard for that. So how it works, I'll explain very quickly. So here, the first thing is that when it says it is flexible, which means it is supporting something called as flexible schema. Now, what is a flexible schema? So whenever you are defining a table, you are creating a table in SQL-based database or relational databases. So you issue a command, a statement, create table name, and then you specify the attribute names, their types, any constraints related to them, and so on. And then every record in your table that you are inserting has to follow that same schema. In DynamoDB, every record, which technically we call as item, it can have different numbers of attributes, it can have different types of attributes, right? So that is what we mean by flexible schema. So record 1 or item 1 can have 3 attributes, item 2 can have 5 attributes, item 3 can have 10 attributes, item 4 can have 4 attributes, and so on. And these attributes can be of different type as well. So that is what we mean by flexible schema. So that is one thing. Other than that, DynamoDB supports a lot of features out there. So first of all, from security perspective, your data is encrypted by default. Second, it supports the TLS encryption for data in motion. Third thing, you can set up the IAM policies to protect your data or protect your resources at table level, at item level, that is record level, or even at the attribute level. So you get a very fine granular control, access control over your data when you're using DynamoDB tables. And again, you have the regional and global options. So there is a feature called global tables in DynamoDB table, which allows you to set up a multi-master database setup for your DynamoDB tables, which means that exact replica of a table. So let's say you are going to create a table called music, and if you enable a global table option for that, then you select which regions you want to create a replica in, it is automatically going to create exact replica of the same table by the same name, music, in the selected region. And not just that, it is also going to synchronize those tables with each other. It is going to replicate that data in every such replica table. And this replication will be asynchronous replication. So which means you can expect some delay, some inconsistency in the data for a while, but eventually this will become consistent. Okay, so that essentially allows you to set up a multi-master database or table kind of architecture across geographic regions. Again, what are the good use cases of DynamoDB? Serverless, it can be used as a serverless for serverless web applications. Microservices data store can be used for mobile backends, ad tech, gaming, Internet of Things. So wherever you have a requirement of very high throughput, and what you can expect from DynamoDB is a single-digit millisecond. You can expect a single-digit millisecond throughput. This can be further enhanced to a single-digit microsecond throughput when you are using something called as DAX or DynamoDB Accelerator. So this is the kind of throughput you can expect from DynamoDB NoSQL solution. So again, with these, the real-time gaming things, ad tech, IoT. So these are certain use cases where DynamoDB becomes a very, natural choice. Of course, these are also the use cases where you are going to use DynamoDB, especially with these serverless web applications. You will find that DynamoDB finds a very, suitable place there. Other purpose-built databases which are there like Redshift, Amazon Document DB, Neptune, and so on. So depending upon what you need, you are going to use. Now again, this is not a comprehensive list. There are so many database services available in AWS. So it's a good idea to go ahead and take a look at them. Okay, just give me a second to get some water. Okay, great. So just to summarize, what are my requirements and what should I do? So if I want to use enterprise class relational database, I'm going to go with the RDS. So please remember that I need to use relational database, and hence I'm opting for RDS. If I need to use fast and flexible NoSQL database service for any scale, I'm going to use DynamoDB. I need operating system level access or application features not supported by AWS database services. Then I'll go with a DIY solution, which means I'm going to install and manage the database on a provisioned EC2 instance. Specific case-driven requirements, machine learning, data warehouse, graphs, etc. So there are so many other purpose-built database services that I can refer to and use them for my purpose. Okay, with that said, a good time for a quick knowledge check once again on your screens. Which of the following is a key value NoSQL database? So you have the options A, B, C, D. Please feel free to put your responses on the questions panel.
Which of following key value?
Okay, great. So I'm getting a lot of responses from the participants. Really appreciate that.
DynamoDB में आना चाहिए ना, अभी इसमें तो DynamoDB में बताया यार.
Okay, so most of the people it seems are going with DynamoDB. So let's see if that's the correct answer. Yes, that's the correct answer. Very nice. So really appreciate your participation in this participants. Okay, now we want to automate the deployment. So right now we are looking at a solution where or looking at at the steps where I'm kind of manually step by step clicking on certain options, some buttons, some check boxes and things like that to set up my resources for various AWS services. But this is not how you are going to do it in your real life. Maybe you will do that, but not for a lot of times and for a lot of resources. So think of it like you need to provision 100 EC2 instances with same configuration. Are you going to manually launch 100 EC2 instances? Or if you need to create maybe thousands of buckets, are you going to manually do that? No. So for that purpose, we have this service called AWS Cloud Formation. Think of it like supporting the IaaS infrastructure as a code, IaaC infrastructure as a code. So it helps you to model and provision all your cloud infrastructure resources. With AWS Cloud Formation, the first thing that you do is you create a code or you code your infrastructure template in either YAML or JSON format. So essentially, it is a YAML document or a JSON document. Let me show you that on my machine very quickly. So what I'll do is I'll open one of the YAML files, and there it goes. So I'm going to open my file explorer and open some relevant YAML files for you. Just give me a second. Okay. I have this one YAML file open in front of you. Here you see I am defining an EC2 instance as my resource. Now there are different elements to it, like parameters, mappings, resources, then output. So these are the different elements in it. So resources is the one which is mandatory, and this is where you define your resources that you want to provision. So here you see I'm defining an EC2 instance. resource. The type is AWS EC2 instance, and defining various properties for that. Now, if you take a look at this, you will find that it has similar set of properties which we did manually, like setting up the instance type, defining the AMI, and so on. And then setting up the security group, defining the user data and things like this, defining the security groups like this, allowing the various ports, opening the various ports, and so on. So again, instead of manually manually launching that instance again and again, what I can do is I can define a template like this, and whenever I have to launch an EC2 instance with similar configuration, I can just go ahead and I can let this template to be used to create these stacks and to deploy to provision my EC2 instances. Not just EC2 instances, but any AWS resources that I want. Now, in that regard, I'll request Nivia to please share the CloudFormation link with the participants. So the CloudFormation service allows you to create your resources, allows you to define your resources first of all, like a code, like a script. This could be a YAML script or a JSON script. Then you check out for your template locally or upload that to an S3 bucket. Then with the help of CloudFormation service, you can create a stack based on your template code, and the AWS, whatever you have defined in your template file, that ultimately gets provisioned on your AWS account with the help of CloudFormation stacks. So that is a way where you can write down. So in a written format, you can tell AWS that, okay, these are the resources with these properties that I want to provision. Benefit is that you can recreate those resources exactly as they were done previously. If you need to do any modifications in their properties, etc., that can be backtracked. You can store these CloudFormation template files, which are nothing but a YAML or a JSON file. You can store them in your code repositories, in your source control environments. And hence, you know that by when, by whom these resources were changed or their properties were changed. Okay, so you have a better control over your infrastructure. And again, you do not need to do those steps manually again and again. So you get the benefit of reusability as well with CloudFormation. Great. So this architectural diagram helps you to understand that you can set up using the elastic load balancing, using the auto scaling group. You can achieve high availability, scalability, fault tolerance, etc. And then you can make use of the CloudFormation services like CloudFormation to achieve this infrastructure repeatedly and reusability. You can use that with the help of CloudFormation. You can recreate this infrastructure whenever you want, wherever you want, in whichever region. And then, of course, you can use other services for storage, for databases, for logging, etc., monitoring. So, this is what you achieve. Great. So I can see there are a lot many questions. Okay, when you say will we be based to see steps and confirm before provisioning? Now, the very first time you are doing it, it may not be possible, but when you are updating the CloudFormation stacks, at that time, yes, definitely you can see that what differences would be there, what resources will be removed, what will be upgraded, how they will be updated, which will be the new resources that will be provisioned. Now, if you think that it is looking good, you can go ahead and you can go ahead with the updation of that stack. But if you think it's not good, you can go back and you can remodify your template, and then try to update once again. So with the help of CloudFormation update stack update, you can do that. Great. So with this CloudFormation, I'll just stop for a while here. And I'll talk about the security part now. So because that's something very important when people are kind of trying to move to AWS, or for that matter any cloud service platform, security is one major concern for everyone. So how do you secure your infrastructure in AWS? Security is basically the top most priority in AWS, and it's a day zero job. You will, as a customer, you benefit from a data center and network architecture that is built to meet the requirements of the most security sensitive organizations. And the AWS architecture has been architected to be one of the most flexible and secure cloud computing environments available today. So the environment is designed for security, constantly monitored. It is highly automated, highly available, and highly accredited. So there are so many accreditations that AWS itself has achieved and keeps on, getting its own infrastructure audited by independent third-party auditors, which allows it to remain accredited for certain compliance standards, etc. Now, at the core of the security lies the AWS shared responsibility model, which the customers need to understand very well. So now here, if you will realize, there are two stakeholders. One, of course, is the AWS, who is the provider of the service, and second is the customers themselves, who are the consumer of the services. And security is something which will be requiring both of them to come together and make sure that the customers are securing their own workloads. Now, in shared responsibility model, AWS very clearly defines that what are the things AWS will be responsible for as far as security is concerned, and what are the things customer will be responsible for as far as security is concerned. So as you can see, one part of the security that deals with is called security of the cloud, where AWS is actually responsible or accountable. So AWS will ensure that their global infrastructure in the form of data centers, AZs, regions, locations, edge locations, they are all safe and secure. Not just the perimeter security, but the environmental security, and then all other kind of securities. Then in terms of foundational service, so say for example, compute, storage, database, network, they will need to ensure that even their internal network is supporting or is making use of the TLS or SSL encryption. Their storage devices are commissioned and decommissioned as per the NIST norms, standards, and things like that. So this is what AWS will be responsible for, making sure the availability of their resources, making sure all the host level operating system software update patches, security update patches are in place. So these things AWS is going to take care of. So basically, any hosts, network, software, and facilities, protection of the AWS global infrastructure, of course, it's a top priority, and availability of third-party audit reports. Then when it comes to the customer, they are responsible for security in the cloud. Now, what are the considerations? First of all, what should you store? Which AWS service should you use? Which region to store in? What content format and structure you should be using? And who has the access to your data or your services or your infrastructure? Now, again, this includes your customer data, platform, applications, identity and access management, operating system, which means operating system here we mean the guest operating system. So when you are creating an EC2 instance, when you're launching an EC2 instance, you are selecting some operating system, maybe Linux, maybe Ubuntu, maybe Windows, maybe Mac, whatever. So the responsibility of securing, making sure that these operating systems are guest operating systems are up to date on your instances. They have the latest security patches and things like that. That is a responsibility on customer. Then any client-side data encryption, data integrity authentication, any server-side encryption of your data, any network traffic protection, that is all responsibility of customer. Now again, for a lot of these use cases, AWS is providing multiple services out there like IAM, Identity and Access Management, like the KMS, which is Key Management System with respect to data encryption. Then there are, ACM or the Certificate Manager that you can use to that you can acquire to create a certificate and for using it for TLS or SSL purposes, and many more other services are out there. So it is up to you, the customers, to make the best utilization of those services to ensure security around these artifacts or these parts. But that again is a secure. So for example, S3. Now, if you talk of S3, by default, it does not allow any public access. By default, it is only allowing the owner of the objects, the buckets, to access them. But if you as a customer, you open that up, you open it for more, publicly accessible, then this is your responsibility to make sure that how you are securing the data in your S3 buckets. Okay. By default, S3 has disabled any public access as soon as you create an S3 bucket. So then it's up to you, how much do you want to open it for the public access. Great. So these are the two parts that we need to manage. We need to understand the shared responsibility model, security of the cloud taken care by AWS, security in the cloud taken care by the customer themselves. So in order to managing authentication and authorization for your infrastructure itself, you can make use of IAM service, AWS IAM, Identity and Access Management. So here you can come across entities like users, groups, roles, etc., which will be the identity part. So you can create multiple users. You can manage those users by arranging them in groups, or you can create some temporary users with the help of roles. Then these identities you can. So this is your authentication part in the IAM. Then comes the authorization part. What these entities can do, what these entities cannot do on different resources. So that is what you control with the policies. So authentication part, like who are you? Do you belong to this account? Do you belong to this place? So that is with the help of IAM user groups and roles. And then comes the policy part. So once you have been authenticated, what is it that you can do? What are the resources that you can access or cannot access? That is defined by IAM policies. So authorization part is defined with the help of IAM policy. And hence the name IAM, which means identity and access management. So identity part is the authentication part. Access part is the authorization part. Okay, then let's take an example of using roles for temporary security credentials. Now, I'll quickly try to do that with the help of my management console. If it has started working, let me check. Come on. Come on. Not sure why it's feeling like this. The resources within are working fine. Okay, no worries. So I'll just go ahead with these slides. Now, let's say you have created an EC2 instance, and there is some application. Think of AWS CLI as a simple application that you have configured on your EC2 instance. Now, from the CLI, you want to execute the command AWS S3 ls. List all the buckets. But this will not be possible. Why? Because by default, EC2 instance will have no access to any other AWS service. Now, as a matter of fact, can you treat EC2 instance as a user? Is it possible to do that? Can you create a user for EC2 instance? Maybe no. So what you can do is you can create a role. With this role, you can create some policy which allows maybe read-only access for S3 buckets. And then you attach this policy to the role. So now this role has the accessibility or authorization to read the S3 buckets and list their objects. Now, when you let this EC2 instance assume this role, so in that scenario, EC2 instance also gets the ability or authorization to access the S3 buckets and their objects in a read-only way. So that is how you allow even various services within AWS account to let access other AWS services, and that is where the role comes in the picture. So role basically allows the temporary kind of a user. One second, please. So role allows to be treated your different services as users, applications, and any services that may assume the IAM roles. And in turn, they use the IAM policy again for the permissions or the authorizations. So that is how the overall thing goes. So again, this slide actually depicts the same idea. So by default, you can see this application is not able to access the S3 bucket. Then you create a policy which is allowing access to the S3 bucket, and this policy is attached to the role. Then your EC2 instance is assuming that role, and hence the application deployed within this EC2 instance is also able to access the S3 bucket. Great. Now again, please remember, whenever you are creating a new AWS account, when you are creating a new AWS account, you are using your email ID. That email ID is termed as root user. Now, please remember that this email ID, which is your account root user, this is not the same as any IAM user. It is absolutely, there's absolutely nothing to do with the IAM user. IAM user is something that you create afterwards you have created the root user. And root user is like a God user for your account, which means it cannot be restricted by any ways, by any means for your account. So root user has absolutely the full control over your account. Now, as a best practice, it is recommended that you do not use the root user account root user for your daily routine jobs. Rather, the very first time you create your account, you log in with your root user, your email ID. You immediately go ahead and create an IAM user, assign it the administrator privileges, log out of your root user account, and then re-log in with your IAM admin user, and then from that point onwards, you can start doing whatever you want to do in your AWS account. So again, as a set of best practices, delete the access keys for the AWS account root user, activate multi-factor authentication, not just for root user, but for almost every user out there. Only give IAM users the permissions they need. So be very specific around giving, granting the privileges, sorry. Then make use of roles for your applications or for other AWS services to access the other AWS services. Rotate the credentials regularly. Remove any unnecessary users and credentials which are no longer required, and keep monitoring the activity in your AWS account. So these are certain things that you need to take care of. So again, I can see a lot of links have been shared. Can we multiple IAM user under root user? Can we, okay, I'm assuming Aparna is asking, can we have multiple IAM users under root user? So see, Aparna, there are no IAM users which are working under the root user. Root user is the first point of entry. So the very first time you are going to create your AWS account with the email ID, that email ID is your account root user. So the very first time there is no option but to sign in with, to enter your AWS account with the help of root user. That is your email ID. After that, you go ahead and you can start creating as many IAM users as you want. Okay, but as a best practice, it is recommended you create maybe one or maybe a couple of IAM users, assign them the admin privileges, log out of your root user account, then re-log in with the IAM admin, one of the IAM admin user accounts, and from that point onwards, start creating as many users, groups, roles, policies, whatever you want to do. Okay, so can we grant all permission to IAM users? Yes, of course, Vinisha, you can grant all the IAM permissions to users. You can do that. Great. Right, so I know I have already overstretched the time a bit. Let me finish, complete this session with a last remaining topic, which is around the pricing and support. I'll quickly cover that. Maybe just 3-4 slides are there. Okay, there's a question. Let me take that up. If my custom web application have different roles like employee, manager, director, etc., can I manage through IAM? See, these are two different things. So the roles that you are talking about, of course, you can define those kind of privileges, those kind of policies, and then attach them to the roles, IAM roles that you might be creating. So definitely that can be done. And of course, the application roles that you're talking about, that can also be handled with the help of another service which is called Cognito, AWS Cognito. So you can make use of both the Cognito and the IAM service together to handle that scenario. Okay, let me pick up another question here. There are a lot of questions coming up. We have to give, after giving full access to IAM user of EC2, but that not able to launch that instance, is a problem. Okay, maybe I think sorry, Chetnatma, your question is not clear. For IAM, we need to create same ID or a different ID. So Zayed, I'm assuming you are asking in terms of root user and the IAM user, right? So if that's the underlying doubt, so IAM user is altogether different from the root user. So again, there is no question of similar or different IDs. IAM user is a different entity altogether. Account root user is a different entity altogether. So we can create policies for different features in web application and assign to the role. Right. Yeah. Yes, Saurabh, that's right. So you can create policies for different features in web application and assign to the role. That's right. Can IAM user in turn? Okay, guys, so there are so many questions coming up. I'll request Nivea to please attend to that. And Nivea is actually, I can see that she's already kind of, answering so many queries. So there are more than 700 participants as of now. So I'll request to please bear with us. Nivea is trying her level best to attend to as many questions as possible. And big thanks to Nivea for that. Can you define permissions for a user group and add users to it? Yes, of course, that's what you will be doing. So you will be creating policies, Ananta, and then attaching these policies to the groups. After that, you can go ahead and assign the users to those groups. So all those users in that group will be impacted by those policies attached to the group. Exam related, do we need any practical knowledge for cloud practitioner essentials? Yes, Vinisha, I mean, that is very much appreciated. When you say, do we need as in mandatory? I would say no, but it definitely helps to have some kind of hands-on at least. But again, it's not mandatory, so as to say. Okay, there is another question. If I am user have full access of EC2, then he can launch EC2 instances. Yes, of course, Chetatna, they can do that. If you go for certain services, like for example, EC2 instance, there is something called as reserved instances or reserved saving plan or compute saving plan, wherein you commit to using the resources for a period of maybe 1 year or 3 years, or maybe committing to a specific amount of usage. So in those scenarios, when you go for when you kind of commit to capacities, you get discounts. So that is another way. Third is pay less by using more. So these are kind of slab kind of usages. So for example, when you might be using the first, just as an example, not the exact numbers. So when you'll be using the first terabyte or first 10, for the after 10 terabytes, when you are using another 10 terabytes or maybe another 50 terabytes, so which means from 11 terabytes to 50 terabytes, that slab will be charged per unit, maybe $0.5 per terabyte. So that way you have slab rates. So the more you consume a service for these kind of services which have slab rates, the lesser you pay for the additional units. So that is another way. Now again, for the reserved instances, as I mentioned, first of all, you get the discount straight away for commitment period of 1 year or 3 years. On top of that, you can select various options that are available for payments, for making payments. So you can go with all upfront payment, you can go with no upfront payment, or you can go with partial upfront. So with all upfront, of course, if you are committing for a period of 3 years, you are going to pay for 36 months, right? Straight away. If you don't think that is feasible, and of course you are going to get the maximum discount out there. If you want, you can opt for a partial upfront where 50% you will pay right upfront, and rest 50% will be charged on a monthly basis. Of course, the discount reduces here. And the third option, payment option, is no upfront, where the total cost will be divided by 36. So per month cost will be there, and you will be charged per month for that. And of course, you will get the least discount in this payment method. But nonetheless, even this payment method will entitle you for significant discount over on-demand pricing, which is pay-as-you-go pricing. Pay more, use more, pay less. So automatic volume-based discounts are there. So like as and when you keep on consuming in slab, the price per unit of storage keeps coming down. So and this applies to some other services as well, like EBS and all. When you use more of them, you pay less. Now, pricing concepts will generally be revolving around the compute, the storage, and the data transfer. So how much compute you are utilizing and what kind of compute resources you have provisioned. So you would be charged per hour or per second. So for example, for Ubuntu instances, for Amazon Linux instances, you will be charged per second. For Windows instance, for RHEL, SUSE, any other instances, you will be charged per hour. For Mac instances, there is a reserve pricing for a fixed pricing for a minimum 1 day duration. So you will be charged for 24 hours for that. Then again, this varies by instance type, as I mentioned. From storage perspective, you will be charged typically per GB. And please remember, I have already mentioned you that when you are dealing with EBS volumes, the moment you provision an storage volume, an EBS storage volume, with whatever amount of storage you require, 100 GB, 100 GB, your bill starts right from that moment. Whether you have attached it to an instance or not, whether you have stored anything in that or not, since you have consumed 100 GB of storage or 200 GB of EBS volume, storage volume, you will be charged for that, whether you use it or not. So if you do not want to incur those prices, those costs, you will have to delete that volume. Then the third pricing is based on the data transfer. So generally you will find that whenever there is an outbound data transfer, that is aggregated and charged. Whenever we are sending data into the AWS, so it may be when you are uploading an object to S3, when you are storing some, transferring some data from your local machine to EBS volumes, etc. So then inbound transfer will not have any charges. Of course, there will be some exceptions, but generally you will find in most of the services that inbound charges are not there. Only outbound charges are there. And you are charged typically per GB of transfer data that you are going to do. So these are the three main considerations. And of course, different services will be priced differently. So there will be services like EC2 will be priced based on the computing and the data transfer. EBS will be priced based on the storage volume and again the data transfer. S3 will again based on storage volume and data transfers. And of course, uh, the regions are going to play a role there. Then AWS Cloud Formation services like AWS Cloud Formation, IAM, VPC, they do not themselves, they do not have any charges. They are absolutely free of cost. What you will be charged for is of course the resources that will be associated with these services. So these are the different services and their different pricing models. Okay, so here is a list of some services which do not have any additional charge like PPC, Beanstalk, Auto Scaling, CloudFormation, IAM. But again, you will realize that just on their own, these services are nothing actually. So there is not much usability of them unless and until you associate some resource with them. And of course, those resources are charging. Okay, then we have already talked about the cost estimation tool, which is the calculator.aws. Nivea has already shared that link with all of you. So please feel free to explore that further, the calculator.aws. Okay. Now, AWS free tier. I'll request Nivea to please share this AWS free tier link with all the participants. What is VPC? VPC is virtual private cloud. So basically, you want to get a total control of your network within the AWS cloud. So that you can achieve with the help of VPC. Okay. So when you want to set up a complete networking on AWS with your resources, you want to kind of segregate them based on some subnets and things like that. So that will be done with the help of VPC and its components. Okay, Nivea has already shared on the chat panel the link for free tier, AWS free tier. So please go through that carefully. There are different free models. So certain services, certain limits are free for a year from the day you open your AWS account, and from that point to 1 year down the line. Then there are certain capacities which are free for the lifetime associated with various chargeable. And one important thing that you need to be aware of is that the logs that are created in CloudWatch, they are not removed by default. They exist forever and they incur you cost. So it's always better to go ahead and remove those logs, maybe transfer them to S3, because this can be really, really expensive. If you forget to remove or delete your logs, they just keep lying there for no purpose. It's going to cost you a lot. So yes, CloudWatch is chargeable. Okay. So we have gone through this calculator. Then there is this service called AWS Cost Explorer, which helps you to take a look at your costs that you are incurring. It helps you to also view the forecast cost and usage based on the trends, the past trends. And you can create and save reports, your spending reports around that. This gives you a fair enough idea how you are consuming your resources, what resources are costing you more, what are costing you less, how the current trend will result into your monthly cost for the coming month. All this thing you can explore. You can explore with the help of Cost Explorer. Great. Then on top of Cost Explorer, there is another another service called AWS Budget, which helps you to set up the threshold that you want to kind of be limited about. So for example, you want that your monthly budget should not go beyond or should you should be intimated, you should be informed as soon as your total cost crosses $400. So you can set up that limit using the AWS budgets, and you can enable the notifications there, so that whenever your total AWS cost reaches the $400 threshold, you will be sent maybe a mail or a SMS notification, and you can take appropriate actions on that, on your resources. From the pricing part, let's come to the support plans. So AWS has 4 different support plans available: basic, developer, business, and enterprise. So basic support plan is available for all the customers out there. It basically gives you the customer service. You can access support forums, service health checks, documentation, white paper, and any best practice guides. So that's basically is available free of cost to all the AWS customers. Then the another one is the developer plan. So with the developer plan support, of course, this is payable and have access to 3 additional features on top of basic. So you get access to best practice guidance, clients build how to use AWS products, features, and services together. And trusted advisor, so you can programmatically do that, and third-party software support as well. And when the customers opt for the enterprise plan, which is the top of all the plans, so again, all the things which are included up to business plan, plus the application architecture guidance, infrastructure and event management, technical account manager, and a dedicated technical account manager is provided. White glove case routing is there, and management business reviews are also provided. So these are the 4 different business plans that you can work with. Out of these, the basic plan is what is free. Okay, great. Now, other than that, what you get is the knowledge center support, where you can get FAQs and common requests. You have AWS documentation at your exposure, AWS discussion forums, and AWS support center. So in addition to support plans, these are provided with tailored customer support, and I mean these support things are also available. So basically, from pricing and support perspective, the key takeaways are the AWS offers a pay-as-you-go approach for pricing. Some services have specific pricing factors, and some have no additional charges. AWS simply monthly calculator or the AWS link helps you to. AWS support offer plans to fit customers' unique needs, depends on you, your requirements. Additional supports such as knowledge center, AWS documentation, and discussion forums, they are available for everyone to use. Other than that, there are other support facilities, like, for example, our digital learning library, explore.skillbuilder.com, which Nivya has already shared that link with all of you. Then there are hands-on, getting started hands-on available, and workshops available for different services. So all these things are available free of cost for all AWS users, all AWS customers. With that said, we are done with the today's webinar. I would like to thank you all for joining today's session. I hope that was of some help to all. And I'm really sorry, I apologize for the technical glitches that were there. I have really no idea, I'm not sure why this is happening at my end. But again, I hope you will excuse me for that. And a big thanks to Nivya for being on the chat support today and helping me with this session, and of course answering, I can see Nivea has been really occupied with more than 700 participants attending the webinar. It was really a busy time for Nivea, I would say. So big thanks to you, Nivea. Great. So we'll keep up the session running for a couple of more minutes, and please allow me to share my contact details with you. Just give me a moment. Nivea, if you would also please like to share. Okay, so here I'm sharing my contact details with all of you. That's my official email ID and my LinkedIn, right? Oh, sorry, I've shared that with organizers. I'm so sorry. Okay, I'm putting that on the chat window. So please feel free to get in touch, either using my LinkedIn profile or my official email. So the constraints, as I mentioned right in the beginning, this session is not recorded and will not be able to share any presentation decks with you. But Nivea has already shared a link for the course CPE on our digital practitioner learning course, which pretty much covers the